dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello folks, welcome back to the second day of our event. We are happy that you are joining us again. Yesterday we talked about reactive applications, front-end frameworks, native script, and we even learned how to build a small Chromium extension. So very interesting. Thanks again also for our yesterday's partner of the day, IBM, for contributing an exciting workshop on cloud native security with Java. So overall, the first day was a huge success and already more than 3,000 people have watched it also on demand. So let's see if we can top this today. So what's the plan? Today we will have sessions covering React, Vue.js, TypeScript, TensorFlow and CSS grids. And we will kick off the day with a talk about how to build a Kotlin SDK and as an example connected with JetBrains Space. Feel free to actively join the discussion and ask questions to the speakers. You can do so on wearedevelopers.com/live. There you will find the Q&A tool right beside the live stream. I want also to say thank you to JetBrains, who are our partner of the day and make this event possible. So thank you very, very much again, JetBrains. And as always, before we start, please comply with our code of conduct. Be nice to each other. Treat everyone with respect. Here's a short video explaining it. And in the meantime, I'm going to get our first speaker on stage. Okay, we are back and I am here with Maarten from JetBrains. How are you?
Hey everyone, and hi, I'm good. How are you?
Good, good. Thank you for joining. Maarten, tell us what will we learn from you today?
Today's talk is going to be about building a Kotlin SDK for connecting to JetBrains Space, which is a very descriptive title, of course. The idea is to walk everyone through what we have in Space as a product, what the API looks like, and the thought and process that really went into building an SDK so that you as a developer can start working with Space from your applications.
Okay, sounds very cool. Maarten, the stage is yours.
Thank you. Hey everyone, again, welcome to this talk, Building a Friendly Kotlin SDK to Connect to Space. I'm Maarten, I'm from Belgium, and yeah, let's not waste time and dive in immediately. The goal of this talk is to give you an idea of how you can, if you would build an SDK for an application yourself or for a service that you're building, I'm going to give you some insights into the SDK that we built to work with JetBrains Space, so that developers who want to integrate with our tools can actually work with them better and get started really quickly. Before we do that, I'll quickly dive into what Space is, just a quick overview of what you can do with it. Talk a little bit about the HTTP API that we have in there, so that even if you don't use the SDK, you could still start working with it, but also get some insights into what it does internally. Then we'll look at code generation and what we're doing in the SDK generator itself, because we're generating a lot of code in the SDK, and then talk a little bit about the developer experience that you also may want to include in an SDK that you may be building. Here goes. JetBrains Space is our integrated team environment. If you're familiar with what we do at JetBrains, we build tools for developers, integrated developer environments. We decided to also build an integrated team environment now. What that means is that we have a product or a service, actually, JetBrains Space, where people can join an organization. That organization can then build teams, can build projects, and so on. And Space gives you all of the collaboration tools so that people can work together on projects, do Git repositories, track vacation, have their schedule and agendas in there. So really integrating all those things together. And I'll give a quick overview, an actual demo of the product, so you get an idea of what that integration part really means. So let's do that. So if you create a Space organization, you'll see that you can access it from the browser or from an application as well. And what you'll see when you log in is this homepage, where on that homepage, you will see your, first of all, your daily schedule. If I quickly want to see what I'm up to somewhere next week, I can skip through that and see whatever is happening. I'll see my agenda, but also the important events that matter to me, because this is a personalized dashboard. I can see that there's an Easter Monday there, and one of my colleagues has a birthday. Speaking about colleagues, I can also see the people that I follow or the people that I work with. You can star them and follow them, so you can immediately see whether they are all available or not. The teams that you're part of will also be shown here, and we can see, for example, at a glance that one of my colleagues is unavailable today. If I want more information, I can dive into their profile and get information. If I want to get a full calendar of the team that I work in, I can also see that from there and immediately get at a glance who is on vacation in my team or not. So this is a first part of that integration that I was talking about. Space integrates vacations, calendars, absences, and all of that. Next to that, the idea is that everyone in the company will be using Space at some point. So instead of having multiple tools combined, we have one tool that integrates all tools together and sort of all roles within a company together. Now, in this company, I'm a software developer, so there's a project Ktor.io, and that project will contain people who work on that project. It will also contain code reviews, issues, checklists, repositories, and so on. So for example, I can dive into a Git repository that is there, see commits that are available. I can look at files. In files, I can also see comments that people can add in files in the application. So sometimes comments should not be part of your code base, but maybe you just want to convey a message to your team or ask a question about how something works. Well, you can do that here in Space directly in that repository and ask a question, for example, to the entire team or one specific person. Now, everything in Space is really a chat, and I mentioned integration. So code is also integrated in chats. So if I ask a question about codes, people will, in my team, get a notification in a chat channel, so they can immediately reply to this, and I get a reply back while I'm here still browsing the codes. Same thing goes with issue tracking, same thing goes with code reviews and so on that are also part of Space. They will show up in a chat. In fact, let me quickly dive into the chat there as well. You'll see that I have an open code review where my colleague accepted the changes that I was making. Here, I can simply work with that code review from within chats. If I want the full context, I can switch to that code review, but I can do it from here as well. I can reply to this, start threading, everything that you would expect from a regular chat. Again, I mentioned integration. And let me quickly return to the code comment that was here. My colleague Arjen is on vacation, and again, that integration shows up here. So from within this code review, I can see the profile card of this person, see that they are unavailable. This is also made available when you open up a code review, for example. If I have an urgent change that has to go into the code base, I can quickly see that some people on the team may not be approachable to do a code review because that integration is again available, and that information is available in Space as well. What else is there? There's documents, so you can build a knowledge base and write documents. You can collaborate on documents together. We have some issue tracking in Space as well, where you can file issues. Issues can be assigned to people, can have a status, can have tags, can be added to planning boards. We have code reviews that I already mentioned. There's jobs and automation that you can run. So if you want to do CI jobs inside of Space, you can do so as well. Those CI jobs can then publish an artifact into Space, and we have package repositories for Docker, for Maven, for NPM, for NuGet. All of that is there. What else is there? There are blog items that will show up on the homepage or in this dedicated feed for blogs. Blogs in the company or in your Space organization can be targeted to everyone. So everyone in the company gets that notification. They can be targeted to just one office or to one specific team. So that, for example, if you had a production outage and you want to inform the entire developer team of the root cause of that outage, you may write a blog post just targeting the development team in there. I've been talking about development teams quite a bit. In projects, you have those documents, you have issues that other people in the company can use as well, and we're expanding on that. One thing that I maybe also want to mention is that everything in Space can be a to-do item. So in chat here, if this want to join as well is a message that I want to follow up on at a later point in time, you'll see in a lot of places that there's this lightning bolt icon. If I click that, this item will be added to my personal to-do lists. And I can see there's chat messages in there. There's an issue in there. There's a meeting in there that I should comment on. All of those things are there. I can complete those things if I want. And also if for some reason, for example, this chat message is something that I should take actual time for to work on, what I can do is schedule a meeting to do that and immediately block my calendar to work on a specific task. Now, the goal of this talk is not really to give you a full overview of Space, and I think I spend more than enough time on doing that, but I hope you get the idea that Space is quite a big product. There's a lot of information in there, and there's a lot of internal integrations between all of the different subsystems that are in Space. So let's talk about the Space HTTP API. More information in Space means that you get more value out of Space. If you do vacation tracking or synchronize your calendar with Space, you get that information when you open up a code review. And we have lots of integrations out of the box. Vacations are shown in your profile. Blog posts can be targeted to a team or a location. If you write a blog post and there's an event that you want to attach, you can do that as well. If people RSVP in that blog post, it will be added to their calendar at once. Everything can be a to-do item, whether it's just a random message, a chat message, an issue from your issue tracker, or anything else can be a to-do item. But while we have all of those integrations, maybe you want something more. We want to provide some extensibility as well, so you can build your own custom integrations. But what do you want to build? Which integration do you need? We don't really know. Maybe you want to import data or post data to a chat or import users or import issues, build dashboards, whatever it is, we don't know. So the logical next step was to open up everything and make all of the functionality that is available in Space through the UI also available in an HTTP API. And actually in Space, there's an HTTP API playground that allows you to explore whatever is in there. So I'll give a quick demo of that one as well. So you will see that the sidebar is customizable. And for demo purposes, I already added the playground by default. And in the playground, you will see all of the different modules that are available in Space. On the left here, I'm collapsing them just to give you a quick overview of the number of APIs that are in there. And it's really quite a bit. And as I mentioned, everything you can do through the UI can be done through the API as well. So imagine if you want to send a chat message, you can search for send message. That API is going to be there. I can build my request and say, for example, that I want to send to a channel with an ID that is software development, I think is an existing channel that we have. You can then start building your chat message and say hello, for example. And on the right-hand side, you will see how you could craft this as a curl request and just send some JSON to Space and post that message. If you're using JavaScript, we'll give you some examples on how you can do that. And there's also going to be a preview of what this chat message might look like, for example. If you want to get profile information, that is also in there, for example. If you want to get a profile, I can get a profile for me, which is an identifier. I can get a profile for a certain ID in the company. I can get a profile by username. All of those things can be built here in the API playgrounds. And you'll see that everything changes on the right-hand side there as well. A couple of things to note here while we are looking at the playgrounds, because this is already a short introduction into how the API works, is that if you look at the URL, we're now searching a profile by username. So you'll see username, colon, and then the username as a part of the paths in the API. If we want to fetch just the current user, you'll see that the base URL remains the same, but it's just the identifier of the user that changes in the path there. So later on, when I'll be talking about the SDK that we built, you'll recognize that we have some nice constructs to make it possible to essentially replace this part of the request URL so that you can start working with that. One other specific thing about the API is that by default, Space will return a response, in this case, a profile, with the ID, whether it's archived, the avatar, and all of that included. But not all properties will be included. By default, Space includes those that make sense for a profile, probably a username, probably their name, probably whether they are active or inactive, things like that. But if you want to get, for example, their email addresses, you will have to specify that you want that information. If you want to get the languages that they speak and that are available, you can get that information there as well. And you can start building whatever your response should look like. It's a little bit like GraphQL, but it's not GraphQL because we really wanted to limit the scope of queries that you could write here and essentially just form or formulate the shape of the object that you want to get back from the API. You'll see on the right-hand side here that whenever I check these boxes and say I want to include those properties, all of that is included in a fields query parameter. But I'll talk about that in a little bit. Actually, I'll talk about that right now. The fields parameter is where in the API you specify which fields you want to retrieve from Space. So by default, again, that's going to be most of the top-level fields available in whatever object you want to retrieve from the API. If you want to get more or you want to get specific, you can specify the fields that you want to retrieve. Typically, it's going to be property names separated by a comma. If you want to have properties of another property, you can essentially build that query parameter using what you see on screen here and just say, I want, for example, all of the properties using asterisk, but also issue boards with their ID and description. Could be something that you built there. All right, let's talk about building a Kotlin SDK for this entire Space HTTP API, which is really the goal of this talk, right? We want to make it easy for our users to successfully use Space and to successfully build their own applications that integrate with Space. So our main goal was to provide a couple of ready-to-use SDKs, and we actually have one for .NET and one for Kotlin right now. That would require minimal configuration and that are very, very discoverable in what they offer you as an end user of this SDK. So ideally, we want you to install a package, whether that's a Maven package if you're using the Kotlin SDK or a NuGet package if you're using the .NET SDK. Set up a connection and then discover everything because the API is thought through and gives you all of the different options that are available, and you can essentially discover what you may want to work with in the SDK. In summary, we want to lead you as an integration developer on the shortest path to success, and that's where the remainder of this talk is going to be about. So when we started thinking about building this SDK, we thought first, well, maybe we should handcraft the SDKs, start coding them so that they really feel, in this case, like a Kotlin SDK that people working with Kotlin as a programming language will like and enjoy working with. But we quickly thought, well, maybe handcrafting all of that is not a good idea. We have, back then when we decided to build this thing, we had over 150 API endpoints. I think by now that's close to 200. Something over 700 object types. I think by now that's also close to 800 or 900. And since we only released a stable version of Space in November last year, during this entire time of building the SDK, we had lots of churn because we were in EAP, payloads were changing a little bit. Some URLs were changing based on insights and early customer feedback. So we had some churn there, and handcrafting this would be a very, very tedious task. So we decided to use maybe something like OpenAPI. Our API in the playgrounds gives you the metadata in OpenAPI formats, and you can actually generate your own custom client for working with the API as well. We actually tried that, and we've been using some of the OpenAPI generators that are available out there, but there's some incompatible object types that needed some custom code configuration or code generation. And also the output was not really that user-friendly. It still felt like just a tiny wrapper around the HTTP API calls, instead of being a proper Kotlin SDK that you would enjoy working with. So we thought, well, if we expose our entire metadata model that the API playground uses, maybe we can expose that as JSON as well, and then based on that information, build our own SDK and really make use of all of the types and objects and language features that are available. Actually, there is an API in Space. If you have a Space organization, you can request the URL that you see on screen here, and you will get all of the DTOs, the objects in the API. You will get all of the enums, all of the enumerations like weekdays, like time zones, etc., etc. You'll get all of the URL parameters. So I showed you when requesting a profile that I could select me, a profile identifier by ID or by username. So those are those URL params. And I can get information about all of the resources that are available. If you have a Space instance, do check it out. I don't think a lot of end users are going to make use of this specific API call. But if you want to build your own code generator on top of this API, you can do so using all of that metadata. What we expose, for example, is all of the enumerations that are available in Space. So I already mentioned weekdays, for example, Monday, Tuesday, Wednesday, etc. is typically an enumeration. It is finite. There will not be more than 7 weekdays. My enumeration is going to have a name, weekday, for example. It's going to have all of the values, all of the days of the week, and it may have a deprecation message as well. We decided in the API to also expose whether something may be deprecated after a while or not, so that if we generate our code, we can also add that metadata into, for example, the IDE when you're developing this. If you look at this model, for enums, it's still quite simple. I'll show a more complex one later on. But if you use this, deserialize the JSON from our API into this object model, you'll see that it's quite straightforward to generate actual Kotlin code that is an enumeration. So what we could do is build a string. If there's a deprecation, add a deprecation annotation in there. Then write out the enum class and then the name of the enum. And then for every value, just add the values in code there. If we would run this code for every enum, we can generate something like this, where, for example, for absences, we can have an enum class, absence list mode, and then all of the different values of that enum that are available. For DTOs, the actual objects like a profile, like an absence, like a calendar event, and so on, things start getting more interesting. Our DTOs have an ID. We know what class it is. They have a name. They have fields. Every field can have a name, a type, whether it's deprecated, whether it's optional, whether it's nullable, whether there's a default value maybe. All of that metadata is really encoded into the API. If you would use all of this to generate, for example, a JavaScript client, maybe you don't need all of this information, but since we can reflect on our own code base and expose that model through the API, we thought, well, maybe it's a good idea if people want to generate their own clients and write their own code generator. If not, at least we can use it to build that SDK later on. So DTOs are slightly more complex. For endpoints, you'll see that there's lots of classes and lots of properties and annotations that are involved. So I added a quick unreadable schema on the slide there, but you'll see there's lots of information. What's the endpoint name? What path is it? What are the parameters? What are the return types that will be returned? Is there any defaults or any other options in the API that you can use? So all of that is encoded in there. But for now, let's get started with the code generation that we have in Kotlin SDK. So by the way, you'll find the API client code generator on GitHub. If you go to github.com/jetbrains/space Kotlin SDK, you'll find the code of our code generator there as well. And you'll see that in the generator itself, we encoded that model. So I mentioned that the Space API gives you all of the information that is available in terms of metadata and types that are available. You'll find all of that encoded in this code generator, and we actually had to manually write that model at least. So you'll find enumerations in there, and you'll see that enumerations have an ID, can have a name, and have all of their values. Using this metadata, we can then start generating codes. Now, previously on slides, I mentioned that you could do that using a simple string. We are actually using a library called Kotlin Poets, where we can do something more strong typed and make sure that everything works well. But what we do here is for every enumeration that we have from our model, we will generate a Kotlin class, first of all. And then using that Kotlin class name, we will build that enum using the enum builder of Kotlin Poet, which means we are building an enumeration. And then for all values, we're adding that as a constant to the object type as well. If there's a deprecation, we're adding that to the metadata model as well. And then we call build, and Kotlin Poet emits all of the Kotlin code for us. I'll talk a little bit about Kotlin Poet in a bit, but this is actually a much nicer way of building all of the types that are available instead of just using strings here in Kotlin, because it's really enforces us to be specific. And if, for example, an enumeration has no values, it will also tell us about it, etc., etc. So there's a bunch of checks that are in Kotlin Poets. Now, how is all of this bootstrapped? We have main.kt there. If you want to run the code generation against your own space organization, for example, what you can do is download the metadata model using this URL that is commented there, save it to disk somewhere, and then run the code generator where we then generate types, resources, all of the structures, and some other stuff that goes into the actual Kotlin SDK that we have. Maybe one more thing that I want to mention here. Whenever we need a class name, we have written a bunch of extension methods, for example, Kotlin class name joins. Those extension methods are in our own code base and will replace some invalid characters that we get from the Kotlin from the Space metadata model. We will replace those and write them as a proper class name that is available. We have that for enumerations, but also for classes and other types that are in the SDK. We have those extension methods to quickly be able to figure out what a class name should be. Right. I mentioned that I was going to talk about Kotlin Poets, so let's do that right now. So generally, if you're generating code in Kotlin, there's a couple of ways to generate code. You can either do that strings-based or using templates or whatever, which is quite straightforward, because that means that you would just be writing strings or running a template engine and writing those strings to disk and getting generated codes. It's also really easy to recognize what is being written. If in your code or in your template string, you see that there's an enumeration written, well, it's easy to figure out where an enumeration is being generated because you can map that visually pretty easily. We decided in the Kotlin SDK to go with a model-based approach using Kotlin Poets, and Kotlin Poet gives us some safety. We cannot forget to write the class name, for example, if we are doing this, because Kotlin Poet forces us to give Kotlin Poet a class name. So if for some reason we forget to get some data or deserialization fails somewhere and we don't have that metadata, Kotlin Poet will tell us that something is off and that we cannot generate code because we're missing some sort of data. So it gives us safety. A quick side note here, in the Kotlin SDK, we are using Kotlin Poets and a model-based approach. In the .NET SDK, we're doing something different. We're actually using a string-based approach there because it makes much more sense in the .NET world there. Kotlin Poets is a library that allows you to generate KT source files, so Kotlin language. And I mentioned safety already. It makes sure that all of the properties of code are in place. So if you need a modifier, if something is public or private, Kotlin Poet will always write that out and require you to pass that in. If you have a type name or you don't pass in a type name, Kotlin Poet will make sure that you know that you should give it a type name and so on. A really nice thing is that there's also callable references. So imagine you have a function called hello function, and you're writing that to the output. Well, if you later on generate code that requires you to call that specific function, you can use hello function.reference in this case, and Kotlin Poet will automatically make sure that the correct method name is there and that the generated code actually contains a proper reference when you start compiling it as well. Another really nice thing is because we have so many classes, many properties, and many sub-properties and so on, in the generated code, Kotlin Poet also formats the code that we have so that if you want to inspect this and see if the code generation was successful or really what we expected, Kotlin Poet makes sure that everything is generated nicely. I mentioned extension functions we're using those everywhere. So anywhere we need a Kotlin class name from a string or from a space model type or an enumeration or a DTO, we have those extension methods to give us, for example, a class name for a DTO, for a URL parameter, etc. The reason we did this is that we know there's going to be some cases where we need a class name. So if you add those extension methods, you will, as a developer of this source code generation thingy, you will actually know that those methods are there and that you can call them if needed. Right, let's talk a little bit about developer experience. So far we've seen how we generate code, we've seen what Space is and how we generate code for Space itself. But if you want to build an SDK for any type of application or API that you have, let's give you some ideas on developer experience that you can offer your users as well. So I mentioned ideally, if you want to get started with using Space and developing for Space, ideally, you want to first of all register the application in Space itself because you'll need credentials to do that. Add a package dependency to your Gradle file, create a connection, and then profit. Essentially, everything should be self-explaining. And if you do space client dots and then invoke completion in the IDE, you should be able to easily figure out how you can get started using the SDK. In Space, I mentioned we have a large API surface, and thanks to our code generator, we are actually able to reflect that API surface in the SDK as well. So if you are using the HTTP API playground, you can see that there's a theme directory. In theme directory, there's going to be a service that gives you profile information, and there's going to be a get profile method in there as well. Well, you'll see this reflected in the code that we generate. If you want to figure out how to get a profile, you will quickly find if you hit dot and then completion on your connection that you just made to Space, you'll quickly see that there's a theme directory. Theme directory has profiles, and that get profile method is in there. So a very small thing, but it's really easy to visually see in the API playground what is available, and then quickly be able or easily be able to map that into the code that you may be writing. If you remember fields from earlier, that's a more interesting one. By default, Space will return all top-level fields by default. But if you want to be more specific, you have to pass in this fields query parameter and be specific about the fields that you want. We thought, since that's a query parameter, we thought, well, we could either expose that as a string, so you would have to think about what the property names are and so on, or we could generate something that is nicer for that and generate that string for you as a developer. So we're doing that. If you want to get a member profile from the API, you will see that you can use spaceclient.themedirectory.profiles, get that information for a specific user. If you want to be specific, we're using a Kotlin extension Lambda or a Kotlin Lambda where you can just say, I want a default partial with all of the default fields, but also managers with their ID, their username, their first name, and their last name. So we generated this strong typed. So if there's a field managers and you make a typo or something, the IDE will tell you, or when you compile your code, you will see that it's wrong because that method is not going to exist. Whereas if we would have exposed this as a string, if you had a typo, you would only know at runtime. So we're trying to make it easy for you to, first of all, discover the properties that are available. You'll get completion for these. But also if you make a typo or do something wrong there, the Space SDK will actually tell you, or the compiler will tell you when you forget about something. In the API playground, we are also giving you that information. So I mentioned that all of the services and so on map to whatever is in the SDK. We're also actively giving you some example codes in the playground where if you select, for example, that for a profile you want to get the ID and the name, you will see that reflected in the Kotlin SDK tab of the HTTP API playground, and you'll be able to get just those fields. Building a chat message. I think a lot of people using Space will be building integrations with chats, and we generated some code for that where you can really be very explicit about what the chat message should look like. So it can be a chat message of type block that can have an outline, can have an icon where you have multiple sections. Sections can be text, can be buttons, can be dividers, etc., etc. We generated all those types because we need them to be able to build the JSON that actually send off to the API that we have in Space. But we thought, looking at this example, for example, that there's a lot of things that are not really needed, that you should not even want in code. So for example, chat message.block, yeah, it's there, but I know that I'm building a message. So why do I actually need this specific method to generate a block? Those icon equals null statements, do I really need those? Can't we provide a default icon or something like that? The list of sections, same thing. I'm adding a section there with elements, and there's just too much verbosity. So what we did is we generate this as a piece of code, but in the SDK, we also wrote some manual overloads for this and wrote some helper extension methods in a custom DSL to actually make this much nicer. So instead of all of that verbosity of building a block of messages and adding sections and a list of whatever elements should go in that message, we have this nice DSL where you can format your message like you would expect it. You can still use the objects, but if you want to have the less verbose option, all of these things are there as well. For identifiers, we also generate factory methods for most of the things that are in Space. So for example, if you want to send a chat message, you can send a message to a member, private message, to a channel, just any channel that is in the chat in Space. But since everything is a chat, I showed you that code reviews have a chat and issues have a chat and so on. You can actually use those identifiers there as well. We generate factory methods to quickly discover that a recipient of a message can be one of those 4 types. If you send it to a member, we've shown in the HTTP API playgrounds that you can send a message or to me, to a certain username or to a certain user ID. Well, again, by generating some codes, all of the code completion in IntelliJ, for example, will pick that up and again guide you towards success and show you what profile identifier types are available. I'll quickly show you a couple of other things that we have in code, just to give you an idea of the things that you could also build in an SDK. There's my sample projects. So I mentioned that ideally you want to install the package for Space into your application, then create a connection and get started. Well, that's what you see here. We have a Space client and we generate that connection. We can then get profiles, and you can do that using Space clients. And actually, if you use that one and you type a dot there, you will see that completion will give you information about what services are available. So if I want to work with projects, it's self-explanatory. I can discover that that thing is there, and I can get information about certain projects. Same thing in team directory. If I type a dot there, I will see whatever is under the team directory. If I want to get information or just a couple of properties from a specific profile, for example, I can write a lambda there and I can say, for example, that I want to get the username, but I will get completion for that as well. Again, by generating these things, it's easy for me to discover what properties are there without having to jump to the HTTP API playgrounds and figure out what is there. Of course, I mentioned that by default, we get the first level fields that are there. If you do decide to be specific and only get the ID, but later on you will request the name and first name, it means the data is not going to be available. Well, what we will do is that the Space SDK will at runtime give you this error message saying that you did not request the name property and that you should probably add the name property into the request that you are making. The other thing that I mentioned is sending a chat message. Here's the full example with that block, very verbose. We have that DSL where you can actually scope or write your message using that DSL and start working with that. I also mentioned factory methods that are there. So again, if you want to send a message to a certain recipient here, you will see that we have a member there in code completion, and it's a little bit off probably because I have existing code, but you'll see that you can send a message to a member, channel, code review, issue, and if later on we add more, the SDK will be regenerated and we'll have all of that information available as well. If you send to a channel can be an ID and a name. Well, again, you will see that code completion will give you a from ID and a from name that you can use to start generating the chat channel identifier in this case. There's a couple more examples in the README, but given the interest of time, let's wrap it up here. So in conclusion of this talk, I would say, if you didn't know about Space, Space is there. It's an integrated team environment trying to combine a lot of different tools into one with out-of-the-box integrations. We have a very rich HTTP API that you can use and that really exposes everything that is in Space. We have a ready-made Kotlin SDK and also a .NET SDK that you can use to interact with Space. And the goal of that one was to essentially build something that makes you successful integrating with Space by giving you something that is ready-made, requires minimal configuration, and is very discoverable in terms of properties and methods and services and data that is available. We've seen some background. We're doing code generation based on a model that Space exposes. And using code generation and some manual work, we are actually really trying to focus on developer experience. And you can essentially discover things because we are focusing on that developer experience. With that, thank you for joining us today. And I guess we can cover a couple of questions that have come in.
Maarten, thank you very much. So let's see if we have questions here. Yes, there are already a couple of ones. I also encourage everyone, if you have a question, you have now the chance to use Slido. If you use Slido directly, use the hashtag WeAreDevsLive. And Maarten, thanks again. Let's start with the first question. I think it's a simple one from you. Can you integrate it with VueTrack as well?
So right now, out of the box, Space comes with its own issue tracker that is available. So all of that is there. You can integrate it with VueTrack. We are still working on expanding that integration. Right now, I think we have a link between source code and whatever is happening in VueTrack, but the idea is to also do status reports and things like that. So it is possible, being, it's still kind of limited right now, but it's being worked on and expanded, yes.
Mm-hmm. Okay, thank you. Then the next question, I think it's a more practical one. How would you back up all the data over the API?
Good question. It's an easy one. I would say use the API to get all of the data. So that's the easy answer. The more complex answer is going to be that right now, if you want to get backups, there's no single API endpoint that you can call if you want to get all of the data that is available. So if you want to get all profiles, all projects, all issues, all repositories, and all of that is there, you would have to use all of the different APIs and get that data so that you can get a backup copy there. If that's really something that you want, I would suggest we have an open issue tracker for Space. If you want to file a feature request there to get just one endpoint or one place in the product where you can download a backup of your data, that might make sense. So do feel free to add it.
Okay, thank you very much. And then the third question, is it only possible with Kotlin?
It is possible with more than just Kotlin. So I just showed you how we built the SDK for Kotlin. We have a .NET ready-made SDK as well. If you're using the Kotlin SDK and you're using Kotlin JS, so the JavaScript version, you can use that as well. And if you're building a web application in React, for example, and you're using Kotlin JS, you can make use of that one in the browser as well. That said, those are the two only official SDKs that are available. If you want to work with this from, let's say, PHP or Python or whatever, you can still make use of the HTTP API. If you look at the playground, you'll see the different types of requests that are there, and essentially build your own entry point into whatever is in space. If you really feel that we should have an SDK for a certain language, again, I would say visit our issue tracker and tell us we should build that.
Okay, Maarten, thank you very much. That was the last question, but maybe you want to share something else, maybe your take on the future, what can be expected?
Absolutely, yeah. So I showed you that Space is very much an integrated Steam environment, really having all of those components together. We actually started building Space in JetBrains because it's a tool that we want to use for ourselves. We have different roles, but of course we are a company building software products. So right now, if you sign up to Space, you will see that a lot of things are very developer oriented. There's projects with Git repositories and CI/CD packages, things like that. That is because that's essentially the first vertical that we wanted to have in Space because we needed it for ourselves. The idea in the future is to expand on Space and also give you integrated tooling for other types of roles in companies. If you're marketing or sales or whatever, we will be able to provide you tools for that. We're also working with a lot of partners, which is also one of the reasons why we wanted to have these SDKs already made, so that partners can also extend Space and, for example, provide tools for time tracking or whatever they want to build.
Okay, sounds great.
Space is vast, Space is huge, and I think there's a lot of things that we can still bolt on and make it more valuable for everyone.
Maybe for the ones who are interested, is there some kind of beta program or early access program or something?
So if you go to jetbrains.space or jetbrains.com/space, whatever URL you prefer, you can actually sign up for a free version of Space. There's no real limits there, except in terms of the number of CI credits that you get, and some of the features are not available in the free version. But if you want to give it a go, if you want to do Git hosting, for example, and get some basic CI, you can actually sign up for free and give it a go.
Okay, good. Then, Maarten, I have to say thank you so much for this presentation. I hope that we will have you anytime soon also at another event, and maybe also a physical one in the future.
That would be nice.
To meet in person with all the people and with other developers. So thank you so much and see you next time.
Thank you for having me. See ya.
Bye-bye. So, and we are going in a very short break, just a couple of minutes, time enough to get a cup of tea or coffee. And then we will have a very exciting talk about building UIs that learn. So stay tuned and see you in a couple of minutes again. Welcome back, everyone. Nice to have you here, and I am here with Eliran. How are you?
Great, thank you. Nice to be here.
Yeah, very nice to have you as a speaker and looking very much forward to your talk. Tell us, what will we learn?
Today I will show an example of how we can use machine learning in the browser environment in order to accelerate single-page applications.
Exciting. So, Eliran, thank you, and the stage is yours.
Thank you very much. Hello, everyone, and thank you for joining me. My name is Eliran Natan, and today I will talk about the combination of AI and UI. So more specifically, I will show you an example of how we can accelerate a single-page application that we write in React using machine learning. So let's just start with talking about the actual problem. So we all know that when we are building a complicated single-page application, and we have to import a lot of code. We have some components. We always have those components that are very heavy in the sense that we need to import a lot of code for them. So that in turn might cause the loading time to increase. And then we get to this delay in loading pages. Now, one way to resolve this issue is to use the wonderful code splitting API that React actually give us, such as the lazy loading of components. So here, instead of importing the chart component, I'm lazy loading it, and we will fetch the actual code once that the component is actually rendered. So that solves the problem, but not entirely, right? Because we have just moved the time that it takes to fetch the component to somewhere else. Now, when the user requests to see the chart, it would still have to wait for the prefetching time. And that might harm the user experience. Now, one crazy idea to break this trade-off is to prefetch that chart component. So now I'm using the idea of prefetching. So I can first lazy load that component, and then if I have any smart or educated indication that the user is going to render the chart component, then I can use the time that the user is just staring at the screen to prefetch the chart component. And then it will be seamlessly available for the user. So if I have this indication, I can use the dynamic import feature to override this chart variable, and then I basically fetching the chart before the user ever even asks to see it. And that brings us to this interesting question of how can we predict the next move of the user. And I would even show you another example, which is even more meaningful. Instead of just prefetching a single component, I can prefetch an entire routes, an entire screen in my application. So if I have this routing going on between dashboard and products, I can use the lazy loading API to lazy load those routes. And then if I have any indication about the next move of the user, I can dynamically import that route, saving a lot of loading time. So going back to our question, and that's a significant question, how can we predict the next move of the user? And of course, you can think about a lot of benefits of doing such a thing. So let's try to understand the problem. We have a complicated UI, probably a single-page application with a lot of different triggers, and we want to know what is the next action of the user. So of course that we can order we can follow and keep track on the behavior of the user and have this sequence, ordered sequence of clicks. And our question is, what would be the next click? So we need some intelligent mechanism that can supply that answer. So if we are using a sequence predictor, for example, we can supply the current sequence of clicks of the given user and try to predict what would be the next click. Now, in machine learning, that's the problem of sequence prediction. So that's a well-known issue. And when we are thinking about it in machine learning terms, what we want is that the sequence predictor can receive this input of numbers. Each number can represent a specific action that the user has done. And then it would output this probability distribution. So it will generate the probability for each trigger in our application, or at least each important trigger. What is the probability that the user would hit that next? Then we will just take the maximal argument and derive from that the element that the user is going to hit next. So of course that those predictions will be meaningless unless we train this predictor. This is how we use machine learning. So we want to train our predictor with those examples. So those examples are actually sequences, and the last item in the sequence would be the next click. So in simple terms, we want to feed our predictor with sequences that the user has already done, and then asking to predict other sequences. So we get this interesting idea where the user uses the app and also trains the app while it uses it. And the app can be adaptive for the behavior of the user. So if our user changes his behavior during time, our application would know to adapt. So talking more specifically or diving into this magical predictor, what we are actually looking for is a neural network. So a neural network acts as a function approximator. This function receives this matrix of numbers and outputs a probability distribution in our case. So this matrix of numbers, we basically wanted to assign a number for any trigger that the user can hit. And we will not use these normal numbers like 1, 2, 3. Instead, we will use a one-hot encoding. So each trigger is encoded as a string of zeros with a unique one somewhere in that string. And we do that because we don't want our neural network to try to find some correlation between those numbers, those natural numbers. So we break this numerical correlation that we don't want to include. And eventually, we take the output of the neural network and checking the maximal value of it. Once we have the maximal value, we can attach it to the trigger. Now, this is not just a simple neural network. Here, I'm using a one hidden layer, which is an LSTM layer. So that this is a layer that is adaptive or more correlates to finding to do sequence predictions. And my input layer should be consisted of the number of units that matches the length of the sequences that I check. And the number of units in the output layer should match the number of actions that the user can do, or at least those actions that we are interested in. Now, once that we have this output, we can attach it to a certain part in our UI and assume that the user, or that's an educated guess that the user is going to hit that element. Now, implementing such a thing in the browser environment is pretty easy if we are using the TensorFlow.js library that is based on the WebGL, and it allows us to come up with this machine learning algorithm. I personally really love this library because it allows me to run any machine learning algorithm in the browser environment, which can be very convenient. So I'm using the sequential command here, and then the sequential command allows me to stack layers to my network one after the another, and then I add the LSTM layer, as I said. The number of units in the hidden layer is arbitrary, and you can check measure the results and see what is the right number for your specific application. Of course, that we can specify here the activation layer and so on. Now, once that we have come up with this network, we can always ask it for the prediction given a specific sequence. So this is very simple. It's done using the .predict command. Yeah. So now comes the training part. As we said, it's not enough to ask the network for predictions. We also need to train the network accordingly. So this is also very easy. We are using the fit command, and we supply the fit command with this batch of sequences that correlates to a batch of labels. So each label correlates a specific sequence, and the label represents the item that is the next click. So if we have chosen to use an 8 length sequences, then here we would supply sequences of 8 units and another item, which is the 9th click. Now, of course, the training takes time, and we can use the property that the fit command is asynchronic. So we can do the training asynchronously without the user even noticing that in the background. That's very important. Now comes the question, and it's also an interesting question of how we can link between the predictions that we are doing to the idea of prefetching that we have discussed earlier. Because one challenge here is that most of the time, those components that have those triggers that show other components are not always in the same place or in the same hierarchy in the application as those components that actually render and prefetch the component that we want. So we need to find a centralized way to communicate between the predictions that we are doing and the prefetching that we want to do. So if we have this item, this button somewhere in the app that meant to show a chart, and we can always wrap it with this prediction link, some custom component that I call prediction link, and that component would interact directly with a React context. So now we are using the context feature, which allows us to have this global state that is available through the entire app. So the prediction link is connected to the predictor context, and in the predictor context, we can implement all the logic that we have just described, all the neural network, the TensorFlow.js, and everything. Now, this predictor context can supply the next prediction on each state, on each step of the progress of the user. It would supply it to the prediction link. And now this prediction link can expose a handler that I call onPrediction. And when that handler is triggered, meaning that the show chart is probably going to be hit next, then we communicate with another React context, the prefetcher context. That context is responsible on prefetching the associated components. So somewhere in the app, because the prefetcher context is also available through the entire app, somewhere in the app, the appropriate component that fetches this chart can use this prefetcher component and dynamically import that chart. So this is a way to link between the triggers, the buttons, a button that is called show chart, to the actual component that render the chart and import the chart. Now let's just see how it goes in code. So we have this component, some component in the app, and we have this button in the app. The show chart, we are wrapping it with a prediction link component, and this prediction link would expose the on prediction trigger. Now that would be trigger if this button is predicted to be hit next. Now, if we dive into the implementation of a prediction link, and this is very straightforward, we just use the use context React hook to get connected to the predictor context, and then we query that predictor for the current prediction and asking if this current prediction link is currently predicted. Now, of course, that if we want our predictor to be available through the entire app, we should wrap the entire app with a predictor provider. Now, once that we have this prediction link that triggers the on prediction event whenever this button is predicted, we can communicate with the prefetcher context and basically announcing that someone else somewhere in the application should prefetch the chart component, because it is going to be requested or needed very soon. So now, if we are going back to our dashboard component, where we actually import the chart and render the chart, then we could use, again, using the use context hook to connect ourselves to the prefetcher context, and then we query that prefetcher context, asking if the next component that is predicted is the chart, then we use dynamic imports to override this variable. So this is a very straightforward way to allow us developers to easily connect between predictions that we do for certain triggers that are interesting to certain parts of the application where we import the portion of code and render them. So of course that if we want our prefetcher provider to be available throughout the app, we have to wrap the entire app again with this higher level provider. Now we can do that for even for the example of routes, and the prefetching route has a much stronger effect on your performance. So what we are doing here is lazy loading or dynamically loading those routes using the prefetcher context. Now, let me just summarize everything that we said. So basically, React code splitting API can definitely improve the application performance using a lazy loading. So we can lazy load code using the .lazy API. Now, lazy loading and prefetching together can further improve your app performance. We can override and basically using dynamic imports to fetch components while the user is still staring at the screen. Now, we can implement a machine learning-based click predictor in the browser environment using TensorFlow.js. We have seen that for this specific task, we want to use the LSTM type of network. And we saw that we need our output layer to match the number of special triggers that we want to predict. Now we can use React context to link between UI handlers and predictions. So using this by wrapping all the interesting triggers with a prediction link component, we can receive those predictions and then trigger those handlers. So we can do a lot of things upon predictions. In this specific session, I'm just showing an example of prefetching upon prediction. But of course, that you can do a lot of other interesting stuff with predictions. For example, highlighting certain components that you know the user is going to hit. So once that we have this trigger, and basically, we basically want to announce the entire app that this button is predicted, then we can communicate with another context, the prefetcher context, which is responsible of announcing. It really acts like a messages bus, responsible to announce the entire app that this button, this context is required. So, and of course that we have other components in the app that consume this information. So we can use another React context to link between predictions and prefetching. So that's basically the idea that I wanted to show you. And now I would love to hear some questions if you have any.
All right, give it just 1 second. We'll be right ready with the questions.
Yeah. Yeah, we'll go back to the presentation itself.
I was just grabbing my own coffee in the meantime.
Yeah.
So let me see if we have some questions already. Okay, so there is one question, and it is it correct that you do not reuse the trained models across client front-end instances?
The training model Well, if I understood the question correctly, we are implementing it exactly once inside the context, the predictor context, and then the entire app can consume it. So we're not implementing it twice. We're reusing the single implementation.
Okay. And another question, on the training stage, you collect training dataset based on user behavior, all in the browser. How do you store the model for later use?
Oh, that's a great question. Thank you for that. Yes, and that's I think important to mention that that's really about the implementation or the need or the use. We can store, and it's very easy to do that with TensorFlow. We can store the trained model in the local storage of the browser, for example, if we want to keep following a specific user as it behaves in that specific browser. But of course, that we can take it to a more global level. We could store the trained model somewhere in the server, the cloud, and then we can follow or make our application adaptive to this user wherever it uses the app, or maybe when it uses it in different devices. So it's really up to you to decide what is the level that you want to maintain or to preserve this trained model. Just know that it's very easy to save or store this model somewhere. We are just keeping those the trained model as wages and use them wherever we want.
Okay, then there is a question from Lorenz, and he's asking, how much data do you need for the model to work properly? So okay. I think he's asking about the training.
Yes, that's another great question. Thank you. So that's really about your app, your users, and your data. So when I tried to test this platform in a certain application, I realized that I need a couple of hundreds of interactions with the application in order to start getting some interesting predictions. But if you just by fine-tuning the arguments and the parameters that you are using for your network, you can find out that you can make your predictor much better. So it's really up to the specific clients and specific users, the character of those users, the structure of the app, and the fine-tuning of your model. You can also think about a shared model where you have one model that tries to predict the behavior of a lot of users at the same time. It might be even more beneficial because then you have a lot of interactions with that model. So there is a lot to discuss here if we want to take this solution and give it some specification for a specific application.
Okay,
definitely.
Then another interesting question, a follow-up question from before. Why did you choose this solution versus training the model based on client log data, navigation across views, perspectives across all users?
Yes, and that's another interesting discussion because if I got the question correctly, we can definitely think about models that share data among different users, and also the mindset that the predictions should be based on the past behavior of the users and not on something else. Like we could take the type of that specific user or its location and then figure out or blend the computation to figure out the next click. So of course that the prediction of the next click is not only dependent of the past behavior of that user, but also on other stuff that we can combine into our model. Our model can become very sophisticated in time. Definitely.
Okay, there's more questions coming in, but we have still plenty of time. One question is how to control training and prevent overfitting with per user approach.
Yeah. So that's a risk that we take, and in order to avoid this overfitting problem, you first need to make sure that the parameters and the architecture that you choose for your network is suitable for the character of your user and the structure of the application. So I think that you can set up this checker, you can set up this tester that actually checks how much hits and how much misses you had for your predictor, and then you can figure out if your predictions are effective or not. Then by adjusting the parameters of your network, you can get a more accurate predictions in time.
Okay, then the next one just came in. How to... Oh, this was the last one. So how do you... No. Where is the right one? Ah, yeah. Is it possible to have a basic example of implementation small app?
Yeah, so I don't have the example here, but I really want to publish it soon on my GitHub. And that application was very simple. I had a couple of buttons, and I basically used this a user that has a specific path in mind, but my automated user sometimes changes its behavior in a random way, and I ran it against my predictor to see the benefits that I get. And indeed, after a couple of interactions, I saw that my predictor is keeping up the changes and adapts accordingly. And I also saw the time that I save of prefetching components. I deliberately used a very large components that I import, and I saw that this prefetching is quite helpful. So I hope to publish it very soon.
That would be nice. Then next question. Okay, the question with overfitting we already had. So we can basically move that out. And then how do you monitor if the training goes well or if you are on a wrong path?
Yeah, so that's I think that I already referred to that. You can have a measure. You can compare between your predictions on each time and the actual click that the user have done. But that's quite tricky because you're already doing that when you're training the network, right? So even if your predictions are wrong for some time, then the model should adapt because that's the entire idea of supervised learning. Your user supplying the examples to the prediction model. But of course that you can have these configurations of parameters for your training that are not good enough for an effective training. So you might have a very good you can have a very good training, but it would last years. So it's really about finding the right combinations of parameters. And I know that today we have progressive ways to do that, even to use I have read that we can use the swarm intelligence mechanisms or algorithms to fine-tune our predictions model and so on.
Okay, and the last thing for this session is not a question but a comment. So Ilya is saying it would be awesome to have a repo to cooperate playing on it, and he's thanking you for the presentation.
Thank you very much. And I really think that that's the next step.
Yeah, that would be great. So, Eliran, thank you so much for joining us today. I think people have enjoyed it. It is a really cool project. Let's see how it will end, and maybe you can join us in the future again.
Oh, I would love to.
So we can learn even more about that. So with that said, we are going in a short break again. We'll see each other in 25 minutes with our next talk. Also very exciting, TypeScript, React and atomic design, a match made in heaven. So looking forward to that one. See you in a couple of minutes.
Bye-bye.
Bye.
job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now. job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to 130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
So, welcome back everyone. We are going into our next session and I'm here with Nathalia. Hi, thanks for joining.
Hello, thanks for having me. Hi from London.
Oh, how are you doing?
I'm doing very well, thank you. It's a beautiful day today in London, so I'm 1 hour early compared to you guys in Europe.
Okay, and no British weather?
No British weather. We actually have a British summer since 2 weeks ago. I'm not sure what's going on. There's still complete social isolation, but there's a beautiful sun outside, which I haven't seen in London for the past few years. So it's quite crazy. It's beautiful.
No, that's nice to hear. Nathalia, tell us, what will we learn from you today?
Okay, so I'm going to go through projects in front-end architecture. So you have many different ways of doing your architecture in your front-end. I'm going to show you one of them, which I think is the best I've come across so far. And so I will show you exactly how to get started with it and why it's a good choice and how scalable and maintainable it is. And it's a great choice for both, startups and big companies alike, because, every startup is going to grow into a big company, hopefully. So you have to be a bit more strict with your best coding habits from the start, especially with high growth. You need to, have new engineers on board, and your architecture needs to be spotless. So that's what I'm going to present to you.
No, sounds very cool. So Nathalia, thank you. The stage is yours.
Thanks. I'm going to share my screen. So welcome to my talk, Atomic Design with React and TypeScript, a match made in heaven. I'm Nathalia, co-founder at Custodian with Jeremy Hindle and Charles Clegg. And how this talk came about was that I started doing this company with no experience in coding something which was maintainable and scalable before. My co-founder Jeremy did, and therefore I learned a lot from him, how to get around that. And I learned immensely on my own by basically looking at how big companies did it and do it. And I'm pretty happy with it. We are onboarding, new engineers, and it's going smoothly. And for myself to make changes and to make updates, and if we have any change in features or design, the code is so reusable, it doesn't take time at all. So let's go through it. So when I started the company 2 years ago, as I said, I never really built large scale applications. I was extremely good, however, at products and building, MVPs and iterating on things very, very quickly. So I was basically what you could say a serial hacker. I was going on so many hackathons, and every weekend I coded a new project, a new sort of app, and it was really fast. The problem, though, is, I was hacking and not really building something. And I think that's something which is really difficult to learn how to do yourself, because there are so many tutorials on how to make a library work or how to make, a specific design in CSS, but you don't really have a tutorial on how to build very, scalable, maintainable code of great quality, because it's more difficult. And also perhaps it depends on the company. People in big companies take it for granted. People in startups don't have the time to write those articles. I think there are a lot of reasons why, you can't just Google online, hey, best front-end architecture ever, and have everything sorted for you. So what I learned is that, I had to change my way of doing things. React web apps quickly become completely unmaintainable if you code them on the fly. And I could imagine how much of a nightmare it would be to, communicate between developers, to know what they are doing, where they are building the new things, to explain to them what they can reuse, what they can't reuse. I was imagining in my head 2 years ago, how am I going to make sure that we can grow the team consistently with, trust and without having this constant communication. So that's what this is about. As a bottom line, what I thought I needed to learn was, I needed to find a system, a sort of workflow where I can keep a low developer overhead, where, in order to code something, it's not going to take me like one entire day to talk with other people and understand how we're going to make it happen. The structure needs to be so clear. You can have like a 5 minutes meeting and everyone understands each other in the same language and know where things should be. And also, even though I really wanted something which was very well structured and maintainable, in my head, it was in contradiction with the fact that it may not allow flexibility. If I needed to change something, I was there like, okay, well, how do I change something if it's so rigid and the structure is so dictated by something at the start? How am I going to do to change something? And actually, I realized that it was not a contradiction at all. Having a very clear systems and having really clear structure just allows for even more flexibility, because then, you can change across your whole application at once something without having to say, oh, in order to change this feature slightly, we need to change the code in 3, 5, 6, 10 different files. You just have one file which contains, the same reusable UI, and therefore it's more flexible. If I decide tomorrow that the whole application needs a new vibe and, new fonts, new button themes and stuff like that, it's a 5 minutes job. So here's what happened. I went to Jeremy Hindle, my co-founder, and I said, what should I do? What do you think is the best practice? And he said, I'm still learning myself. And what you should do, however, because that's your responsibility, go and, I'm quoting, build on the shoulders of the giants. He said, go and see how Airbnb did it, because Airbnb in our head was, we took so much inspiration from them. They're an app where their UI system is so clear and nice, and their UX is always very consistent. The front end of Airbnb is absolutely amazing. They have achieved something really great. It's not messy, and they have so many engineers, and where they're like, they definitely did something right. So I went and saw how Airbnb did it. I've read a lot of articles. Thankfully, their engineering team is very active in writing articles and blogs around how they do things. So it's amazing. There's so much resources out there. You just need to know that you're looking for it. And this is where I came across their secret, which is design language systems. And at first, when I was reading about how Airbnb did it, and they said it's thanks to our design language system, I thought it was a bit far-stretched, and surely they would have other secrets. I was skeptic at first. One, I never ever heard of it before. As a hardcore, pure like coders, where to me CSS and like all the design was something which was separate to the actual logic of the app, and that was a huge mistake. My way of thinking around that was wrong. I thought design language would be more relevant to designers, to marketing people and branding teams, and therefore I was there like, okay, it's weird that it's not something around the logic of your code or something like that. It was purely based on design language. So I said, okay, well, I need to do some research on, try to get past my initial skepticism and do some research on what it actually means and, in terms of, my code. Again, this is one of the examples of resources you can find online for yourself. The way we build, how rethinking the Airbnb app changed the way we approach design. Like, it's a thing. It's not just me who said, oh, Airbnb is a good idea to, to do this sort of stuff. They are known now in the field as the kind of people who pioneered a whole new approach to how you build software, especially on front end. So let's see a quote of this article. This article actually has been written by Airbnb. So they said, software design has unfortunately not evolved at a similar pace. The gap between designers and engineers has only increased. Design teams can often struggle to reach a cadence that balances the creative process and cycles of continuous innovation. Quality suffers, the experience becomes less cohesive, and talented people spend an inordinate amount of time simply managing communication across disciplines. I don't know if this rings a bell for you. I can imagine that for a lot of companies, this kind of whole bureaucracy kind of, rings a bell. By focusing on the methods of working across disciplines, building better tools, and creating a unified system, we can use our time to apply creativity to solve bigger challenges. Over the coming months, we aim to be fully transparent and release detailed case studies on how our system is defined and what decisions go into designing components, patterns, and rules. And thankfully, by now, they have indeed put all those resources out there, and I'm also going to go through them. So, Atomic Design was what they released afterwards. They went full on to, the detail of how their application is structured. And what they have, kind of released was the fact that they are all centered around atomic design as a methodology, as a way of thinking, and as a way of structuring your actual code. So we're already going a bit more deeper. When addressing these issues, we first had to change the way we understand application design. It was important to stop seeing the apps as sets of pages, but instead as a design system. As a matter of fact, this idea is not new. Brad Frost develops a methodology to create and maintain robust design systems that he called atomic design. Really worth a read, and I second that. Really do read it. Type Brad Frost atomic design. You don't need to read the whole book. There's so much really good resources that he has written on atomic design out there. Very neat, very simply explained, and really you should check it out. His idea was to break down pages into design components in an organized hierarchy. Let's see what that means. So what that means really is that you have a hierarchy of components. And so what the atomic design is how you have chemistry. In chemistry, things are built into each other. You have atoms, you have molecules, you have organisms, and everything, works inside of the same unified system, but every bit has their own role, but every bit also has their own hierarchy. And that's how we're going to think through that. So, even myself right now, when I think of code and when I look at websites and applications, perhaps websites are different applications, I really do not see a set of pages anymore. I'm trying to be there like, okay, what would be the organism? What would be the atom? What would be the molecule? What would be the template? Like all those sort of things. So it's really a new way of looking at all the digital products out there. Once you've learned atomic design, trust me, like you won't look at applications the same way and you won't build in the same way. So design language was actually very relevant to you as an engineer. You can build better and faster, better because, you build a cohesive experience, and both for the users, but also for the developers where things, where everything is and what is expected. And it's faster as well because it gives you a common language to work with. When I say, hey, can you please add an atom? And like this button, for example, is in the atom folder. Can you please add a theme to it? And therefore it's very clear for the developer to know that the button that he needs to redesign is expected to be inside of an atom. Because once you think in terms of atomic design, when you look at a page, a button would always be an atom because it's the smallest bit of UI which you have on the page, which doesn't contain any logic, which only receives the content, and it doesn't do anything on itself. And therefore, input field styling, like everything, it's all very neatly in the atom folder. However, if I give to someone a task which is more high level, and hey, can you please try to think around the logic of how we are going to have the data flow through the forms, that is something which already the developer would know that he wouldn't touch the molecules or the atoms folders of the app, which themselves contain a lot of code. So it's already less confusion as to which part of the code he will have to look at and touch. It would be the organism. So basically, it really does help tremendously in even like across time, for example, in your personal projects. If it's difficult to go back to the code which you started, let's say 3 months ago when you had time, and then you go back to it and you're like, oh, where was I? What was I doing? And where are things that you're trying to understand your own code? And and when you use atomic design, even on your own project, it is not an overkill because your development time is going to be so much shorter because you're going to understand even yourself better over time. So it does take a bit of time at first, which is kind of normal, I would say, because you have to build the system first, and so it's kind of slow at the start. Then everything is much faster. So what is the actual technical implementation? Atomic design, that is the first bit, and TypeScript, which is the second bit. Let's go through that. First, atomic design. As I said, you have the atoms, the molecules, the organisms, templates, and the page. So what you start with is always usually the atoms. When I look at a page and I'm like, okay, I'm going to build this page, I know that at the very end, the page is going to be displaying all of those small elements. So I'm going to create those elements first and then assemble them and then displaying them from the page. So you combine the bits into progressively larger bits until you end up with a page. You don't start with a page and work down. It's a bit like Lego, actually exactly like Lego. You only use small bits, small atoms, which together forms molecule, which are, having the logic made from the organisms. And you have the template and the pages. Templates and pages, I will go through each in detail with some bit of code. It will depend on each company what the template is compared to the page. So for example, as a template, what I have is the different page wrappers. In our application, sometimes I want everything to be centered. And sometimes I want everything, I have a sort of design where I want everything to be on the start of the page. So more like a flex box where things are at the flex start. Sometimes I want to use, there is a part of our app, which is media-like. So you have articles, you have blogs, you have interviews, those kind of things. And there really the focus is on having people being able to read super easily the content. And when you look at Medium, when you look at a lot of content applications out there where it's more like, you read, and that's the whole point of the app. For example, Medium is really good at that. They have the text, which is very narrow in the middle, because the more width your text has, the more effort it will be for the person to kind of scan through and read. So you really want to have like a page wrapper, which is for readable content only, where you want to have like this kind of wrapper where it wraps all the text in the center with a max width, for example, of like 500 pixels. That would be a template. And some other companies will have templates as something a bit more elaborate than that. They might have templates as, for example, an agency of grids, which is like a sort of layout. And yeah, in our company, it's a bit more simple than that. So yes, don't think in terms of pages, think in terms of what the page is made of And try to think as an exercise when you go out there and you use an application, try to force yourself to see things differently. Try to ask yourself, what could be the atom? What could be the molecule? What could be the organisms? Instead of seeing the page as a page. So, the way that you start with is when you look at the page on the far right, this is the page, correct? And what you're trying to break down is, okay, how am I going to build this? Thinking with atomic design. And the way that you build this is you start by trying to understand the smaller bit of UI, which is very simple and does not contain any logic by itself. So for example, you have three kinds of atoms there. You have the rectangle, the orange box, which can contain, or colored box with different themes. You can have this box, which is reusable with blue, orange, pink, green. You have this element. You then have the profile picture, which is like the circle. Okay, that's going to be an atom as well. And you're going to have the text. Okay, you always will want in your application to have text inside of a card consistent. You want to make sure that every time there is a sort of card UI in your app, the text inside feels the same. That's, for example, how Airbnb did it. You can see how Airbnb on the application, they have text which is of exactly the same font size, exactly the same line height across the application. And you achieve doing that by make sure that you unify the source of truth. I mean, unify the truth. You unify your file, and you basically make this file become the source of truth for how things should be in the application going forward, because you're going to reuse it all the time. Then you have the molecule where you assemble things together. And then you have those kind of bits all together up until the page. So you can see how in Storybook, which is like a website which you can yourself access, by the way, it's absolutely amazing how they made it public. They made public how all of their design system is organized. And they made public how all of their small bits are an atom, for example, or a molecule. If you look at storybooks of Airbnb, you can clearly select all the different atoms and see how they look like. And this is how you really understand how they code like they do Lego. Example as well is to check, for example, the UI libraries, and the design is one of them. You have to think of coding your app, and when I say your app, your UI, exactly like if you were coding your own UI library, because your project is using your inner library, basically. So, anti-design is a good idea for you to understand what would consist as an atom, as a UI atom, and they have so many different small components that they have, and you can go through all of them. And therefore, when you're going to code your own version of that, like imagine if your styling is a bit different. Our styling is different, for example, for a multiple selection, for drop downs, etc. I created my own. But when I went to anti-design and looked at the source code, looked at how they made it, I realized how reusable is anti-design. That's the whole point. So many people who use it. And they have so many different components which you can neatly call in your own code. So the goal really is to kind of create your own anti-design. And guess what? Their code base, their code is completely public. You go on GitHub and you check their source code, and they have used TypeScript, which is also what I'm going to mention afterwards. That's how they could build it in a very maintainable way and having all engineers on the same page. So let's go to the code quickly. So on the atomic level, I'm going to give an example. Okay, let's see. What is a very obvious ideal example for you to think of in terms of atom? An atom can be an input field, a single input field. It can be, a button. It can be, you can have the folder called typography, and inside you have, all the kind of sort of headers that you would think of for your app. So headers, paragraph, question, title, very normal ones. Header here on the atom would be more, you have two folders. You have the folder header, then you have the folder typography with header there, for example. Header here on the direct subfolder of atoms would be, for example, the page header, or the header on your, at the very page level. For example, I don't know, welcome page, welcome would be the header. And header in typography means more in terms of paragraph, let's put it that way. So again, it depends on the need of your app. Our app had those needs, and you can see how those to me are atoms. It does not contain logic. It's something that you give it to it, and it does very small UI bits on the page which you can't possibly divide. It's like the smallest bits which you can't divide by itself. Let's see, for example, button. I have a huge button file where I have a switch case, a switch function which takes, in the case of secondary, which is the theme which I would have passed, I'm saying, okay, if there is button with a props theme passed as secondary, I'm going to render the secondary, the button which is with a secondary component. I'm using styled component for those who don't use styled components and are not very used to seeing this. This is how you create a stylized component which you can call within the components. It's like a normal React component, basically, in which you inject CSS. So can you see how how everything is basically unified in this file? My button can contain 30 different themes, and I'm going to have this case function, like this switch and then case, and I have all my 30 themes very clearly. So when you onboard new engineers and they don't know exactly what kind of buttons there is and what are the choices of buttons that they can use and how they look like, you say, go to the button file on the atom, and they can see everything that they can use. They won't need to create a button that doesn't exist. They can understand what's going on there and compare them and, see the props for each. So this is also another example of code for, the atom. Icon is also a very good example of an atom component. Why? Because again, the icon is something which I'm going to reuse across all of the application, and I want to make sure that when engineers have to include an icon somewhere, they don't have to import, an asset and have to style it all the time, all over again, and they don't even know which icon is for what, So I think it's important to have an icon file in your atom folder, where you have all of the different possibilities of icons, and you have a very generic way of styling them. So for example, copy or email or send or info, I know that usually those kind of icons will be inside of a button, and there is no other way in my app where I can have those icons in. And therefore, I'm going to stylize them thinking that it's going to be inside of a button, and therefore they have something like width of 12 pixels. And someone doesn't have to think about it. It's just done for them. And same when they code, they can understand which kind of icon it is without having to worry about the assets behind. Because if I want to change the assets, let's say that I want to change the icon of the email, I only have to change it in one file. I'm saying I'm going to the icon component, I'm going to import the new file image, and everywhere on the application, in absolutely every single use case of having an email icon, the new icon will be updated, which is amazing. You don't have to look for where is your email icon in the code base and I need to change the link of the asset. Now let's see the molecule level. So molecule level is when you have a group of atoms all together. So a very ideal example for it would be, for example, the form fields group folder, where you have checkbox group, radio group form, like all this sort of stuff. Those things are when you have a need to have more than one input field, but same, it does not contain any logic. It's a group of atoms, which is therefore divisible by divisible, and it gives you the atom, but it does not contain any logic. If it contained logic, it would be in an organism. So for example, here I'm using Andy, and with Andy, they have a very neat wrapper, which is called radio.group. And it does it so automatically all of your radio elements are linked together. And it's really nice. So that's one very obvious example for molecules. You can do it the same for like checkbox groups or image list system as well, which I have since even more lists in the molecule. It will depend on the needs of your app, again, but think of molecules as a group of atoms all together which do not contain any logic. Organism level is, again, as I said, is where you have the logic. So this is where you decide, which things to show with certain conditions. So, in this instance, for example, I was creating a form generator where, we had a sort of onboarding system where we could have up to, for example, 10 questions on different pages in a slider. And I wanted to be able to change those questions at any time, because we could change what we wanted to ask, what we wanted to propose, the way that we wanted to ask them, from drop downs to preferences to, anything you might think of. And therefore, I wanted to create a form generator. Way of doing that very neatly, where for the future and forever, whenever we want to have like a nice, nice slides with, a question on each of them, you can reuse this. So in my organism, I'm like, okay, well, if from the page level, I'm asked, to show a form, which is, a theme checkbox, I'm going to show a checkbox form. If I'm going to show, if I'm going to want to have a form which contains radio, I just have to pass from the page level, whatever the name of the file is in organisms, I'm going to call it, and then I'm going to pass the theme radio with the array of items. And that's it. And it does for me everything. And then select search bar as the default. I could also have used the switch case function like I did for the button atom. The difference was that there were only 3 choices, so I thought it was a bit of an overkill. Whereas for the button file, there was, or for the icon file, there was way more choices. Cool. Template, that is an example. Template can be either, again, as I said, a layout or a sort of page wrapper with a specific padding that you'd like to apply. In that case, what could also be a template, and that was the case for us, were 2 things. One, for example, scroll to top was a template, because I'm basically wrapping sometimes like this around my page so that whenever someone goes, changes the page, it doesn't come back to the level where they were, but it always scrolls to the top. Very nice on mobile. And it scrolls as well nicely, it scroll like a nice fading effect as well, because I'm adding afterwards a wrapper, which is with a motion div. And then you can have also your device breakpoints. Again, if you use styled components, this is absolutely amazing, because then you can have the same exact constant breakpoints across your app. And because you're exporting those as constants. And then you can reuse them. Like, for example, you can say @media, and then you insert the constant device.desktop or @media device.mobile inside of your styled components. And all of your engineers will be on the same page as to what constitutes, a breakpoint for mobile, desktop, and iPad in a nice way. There's way more code since then, but you have, we have now like ultra wide. We have iPad, we have iPad Pro. We have 2 different kind of iPads, because we have an iPad which is very large, almost like a computer, but it's a tablet. So you want to make sure that it's, the UI is optimum for something which is going to be touched. And then you have another iPad which is very small, a bit like mobile, where again, it could look even better if you put things a bit differently. So, and everything is manageable from there, which is quite amazing. So now, I haven't touched yet on TypeScript. And because the reasons why TypeScript is so amazing for it are actually quite obvious when I'm going to show you those few slides. And also because TypeScript is a whole new other topic. So I'm really, raising TypeScript here to give you a few examples of why it's amazing and why it's a must, in my opinion. And then you can go away and, learn TypeScript on your own if you haven't yet. So while atomic design ensures that developers are all on the same page to atomic levels, TypeScript ensures that developers are all on the same page to an even deeper level. Everything needs to be defined and expected. So basically, you're making sure that everyone is indeed on the same page with atomic design, and they can't pass, for example, a theme to a button which doesn't exist. They can't, they can't make, if they make an error as to what is expected in your structure, they can't even run the code. It let them know. So you can avoid so many stupid bugs and stupid mistakes. It saved my life certainly at 4 a.m. when I was like coding away like so much, because I just realized that I was making, a stupid typo. And I could have looked for this typo for a long time, and it told me straight away when there was a typo. And you can define what comes in and out of your components and be strict. So you're making your atoms, molecules, and organisms even more robust. Just a quick parenthesis in case people don't know the difference between TypeScript and JavaScript in the very high level. JavaScript is dynamic typing. So for example, programs written in JavaScript do not know the data type of a variable until that variable is assigned at a value at runtime. So, if I have to pass a props, which is of a type string, and I pass a props by mistake, which is of a type null, and I haven't handled the fact that if the props is null, then it should do something that show an empty string. That's going to be a problem. But JavaScript won't let you know because they only realize the problem at runtime. With TypeScript, however, in static typing, what it does is that it throws an error as soon as it tries to compile the code. And therefore, you will see it in your terminal straight away. Hey, by the way, your props is not correct, but not even in your terminal. They have a really nice IntelliSense, which actually tells you straight away while you're typing whether what you're doing makes sense or not. Again, quick example of how you can change the day. So save the day, sorry, not change the day. You can save the day. You have your type declared, for example, in your atom file. So let's go to, input field. Do you remember there was the input field atom and there was the button atom as well? Well, those are the types that you would declare either externally to the files in types.d.ts, which is the jargon to say basically that this type is made for type definitions, or you can put it at the top of your atom file directly. And what you do is you define clearly which props you are expecting, or at least which props you count as optional. Because then when your code, you can see when you hover it, you can see the different options that you have, rather than going to the file and checking, or perhaps making even like when you check, you can make a typo. It's really nice, especially nice when you work with themes. Because again, in theme, I'm having like, primary or secondary or blah, blah, blah. Like I'm not accepting anything else in those. So, when you want to create a theme, you create it, like you style it. And then at the end, when you're happy with it, you can add it to the themes which people are allowed to pass in as props. And again, we'll see what happens if when you try to code something, button theme, when you hover on it, you can see all the different themes available you have, which is pretty sick. And same when you hover on different atoms or any kind of components, really, they tell you, the list of things which you expected to look at. So for example, image credits, I is for interface. So I would know that I would have to check image credits beforehand if I wanted to understand what was going on, what was I expected to see in a very neat place, rather than, if I was just using JavaScript, it would have been way messier. So again, what happens, you can tell me if I pass a theme that doesn't exist. This is kind of the error that you would see, which is very straightforward. It tells you here what themes are acceptable. And it throws you the error, not everywhere in your code, but just on the theme bit, saying that the expected type comes from property theme, which is declared here on type. And it says, type error. Type hello world is not assignable to type primary or blah, blah, blah. It's very clear. It's not confusing. As a bonus, I mentioned Storybook before because Airbnb released their Storybook, where you can go and browse in their different components and see how they are called, how they are structured, what they were made of, what they constitute. And that is absolutely amazing. And I thank them for doing that. And, but anyone could implement Storybook. What Storybook is basically like, it builds for you a sort of website where you have a menu on the right, where you can click on components and you see how they look like. And you click on components with the different props that they are passed in, the different options. It's pretty good. So for example, let's say when you're, when you're scaling with your team and, coding at some point, it's amazing, but people want to visually see the options that they have. Like, it's in my head, it makes so much sense to take the time to create a storybook, because you can, show designers, marketing people, branding, but developers as well, like this website, and then people understand the kind of bits that they have available to them to create new features or, what they can reuse. And that is quite amazing. Definitely do take the time to do that. That's something that I myself will do. I have some of my components on Storybook, the ones I think are the most important. But as we go on, I think it's going to be a must when the team grows to have everything neatly visible on there so people understand what's going on. And, Storybook is something that a lot of people use. It's not just Airbnb. You have Microsoft, Coursera, IBM, the government, Atlassian, and even more people that I haven't mentioned on there. It's very powerful. So if you don't know Storybook, check it. How it works is like this, very simple. And again, having something like TypeScript will be very valuable as well, because then when you create your Storybook components, you also know whether you don't make any mistakes on creating the story yourself. That's how it looks like. So let's start by seeing what we have on the right. So as I said, you have a menu and you can click on each bit and it shows on the left how it looks like, which is quite amazing. And again, with custom arrow, with custom close icon, this is how you can click in it to see, the different options. So let's say I have my button, I can see the different themes on it, which is quite amazing. Or same for icons. If I'm not sure how the icons look, I can go on it. It's great. And again, let's see how you implement it in the code. So let's see at the left, you use Storybook / React as a library. But Storybooks work with obviously any other framework you might want to work with, for example, Angular or Vue. Anything else really? And you create a story of, it's again very nicely written, because each atom is a story and that's the book. So it's the book of the stories. So you're saying, okay, I'm adding one component, so basically one story, which is a button. And then, you're adding, the text, which is going to appear. So, read-only with clear dates button, like all of the things you see in the menu. You are the one who creates what's going to be displayed from the user perspective when you say add, because you're adding the text that you want to be shown on the menu. So for example, I want to show a button with text, hello button, just as an example, theme primary. And then I would have created below all the stories of button. So it's going to be grouped together in the menu. And I'm going to say add, with secondary theme. And then I would have said button theme equals primary, and then hello primary button, or secondary, or whatever theme I chose. So that is very simple. So no matter your level, that's definitely something that you can do. And again, very, very powerful. Cool. So do you have any questions? Super keen to answer any really on architecture, on TypeScript, on React, whatever you want.
Thank you, Nathalia. So let me just open the questions. We have some coming in. So let's see. Yeah, let's take the first one, which is, I think, quite simple. Mr. Anonymous is asking if you can post the slides on Twitter. Okay.
Yeah, I can make a public link of my PowerPoint. And I can post it on Twitter. I will put it on social media.
Well, that's perfect. Maybe you can also tell your handle again.
It's at @girlscode everywhere.
Perfect.
Instagram, Twitter, LinkedIn. LinkedIn perhaps not, but everywhere else.
Okay. Then the next one, can you tell us a few sites using this approach? So this approach, I'm not sure if it is regarding the storybook or maybe the whole talk, but maybe you have some examples.
Usually people who use atomic design in storybooks, and when I say people, it would be big companies, do it together. Companies that would use atomic design would usually have as well a storybook associated, because it's so easy to create a storybook once you have the atoms. You just have to do, as I showed you at the end, like those 3 lines of code, and then you make a story out of your component, and that's it. So usually the two would go hand in hand. I've mentioned quite a lot of big companies that use it. So Airbnb has everything available to see online. That's how it's a good example to see. But also Atlassian does that. Lyft does it. Like big companies really do it. I think I will share the slides again, but there were many companies on there.
Mm-hmm.
Start with Airbnb, because again, every resource is available online.
Mm-hmm. Would you also advise for smaller teams and small projects to use it, since it's still a bit of a work, for a small project to set everything up?
Yes, it is also the easiest time where you can do this is when you're small.
Mm-hmm.
So if you don't start doing this when you're small, you'll never have the time to do it ever again.
That's true.
Because then you will have to recreate all of your code. You have to restructure all of your code base. So if you're a small project, you have to do this, because then you'll never be able to do it. It's the cheapest time for you to spend the time to do this is at the start. Mm-hmm. Because it's where you don't have to refactor anything. You don't have to maintain anything, make sure that nothing breaks when you make changes. Everything is to be built, and therefore it will take you the least amount of time. So this is especially really important for small companies for 2 reasons. One, small companies hopefully will grow. So you'll have, even having 3 engineers on top is a big deal if you don't have a maintainable code base. And, having 3 engineers in your team when you don't have a maintainable code base is exactly as if you had 6 engineers working on it, really, because the time that you spend communicating and, making sure everything is correct, and that you understand when you give a task where the person is supposed to code and what is reusable and not, it's going to take you and suck so much of your time. So definitely do it even if you're very small.
Mm-hmm.
Especially.
Okay, I think that's a good advice. Then next question, can you integrate Figme, Adobe XD, Sketch, etc. with Storybook?
I think so. I have read an article quite a long time ago, so I need to refresh my memory. But there were people who definitely found at least a hack to link Storybook with Figma. I don't know about Sketch and Adobe, because I'm not using it. But I know that people have succeeded to link Storybook to Figma. I just don't know if it was them working around or if it was them actually using an official plugin. I wouldn't be surprised if there was an official plugin, because I've seen Figma and Storybook being used together quite a lot.
Mm-hmm. Okay, then next question. How is Storybook different to Pattern Lab? Do you know something about that?
Pattern Lab, I think it's one of their competitors. Let me check quickly. I have heard of it, but because Airbnb used Storybook, I just went with it, and I've been very happy with it. But if there's something else, I'm keen to learn. But create atomic design systems with Pattern Lab. That is the first link I see when I searched on my phone. Pattern Lab was create atomic design systems with it. So in my opinion, it's going to be something very similar to Storybook. And the thing which will differ is probably the amount of plugins that they have for external platform like Figma, for example, or it would be their UI, and depending on your preferences.
Okay, thanks. Then the next question is, what about using styled components to apply the atomic design approach?
That's exactly what I'm using.
Okay.
If you've seen in my code, every time that there was, for example, the component, which was button with a capital B, that was using the styled component called button above, which I would define with a style. So I agree. Styled components and atomic design work very, very well together.
Okay, perfect. And then last question. Are there any limits of Atomic and TypeScript? Is there things you can't do?
Okay,
with this approach?
so I wouldn't call them limits because TypeScript is basically superpowered JavaScript. So would there be limits to JavaScript? Yes, definitely. And what TypeScript does is making sure that it's JavaScript on steroids. So, if there are limits to TypeScript, they are minimal compared to the limits of JavaScript. You have to see TypeScript as, TypeScript isn't, I should probably not say that, but I see TypeScript not as even as something in itself. I see TypeScript as a superpowered JavaScript. So if there are limits, I wouldn't worry about it because, there wouldn't be something which would ruin your project or not make you able to code a feature that you'd like. It would not be some sort of limits like that. The only limit, it's not a limit, it's kind of a minus, means that, for example, when you want to use libraries out there, like NPM packages, which haven't been, made with TypeScript, sometimes it can run a lot of type errors. And there are fixes to that, by the way. But that is the limit. It's just knowing how to work with TypeScript when you have to use external libraries which don't have types to them, because you can't manually create the types of everything in this library. Like that would be like writing all of the source code yourself. So usually you'd have a library which has been made by people literally like how do you call that, open source, which have @types and then / and then the name of the library. But not all the libraries have that. So the only limit, and it's not a limit because you can go through that. It's just the only minus would be that you would have to learn a lot around how to understand truly TypeScript, so that when it throws random type errors, you know what's going on and you understand how to solve it. I would not say there are limits.
Okay, and then there is another question, the last one. How does the folder structure look like? Do you keep atoms, molecules in a separate folders, or do you group organisms by feature?
That's exactly what I do. So what I do is I have separate folders directly under the source. I have pages. I have pages, and then I have components as a folder. And within components, I have atoms, molecule. I'm even looking at it now because my work code is on my monitor. I have, atoms, molecules, organisms, and within each, I would have different things. So then do you group organisms by feature? Not really. So for example, within each features, you have a lot of reusable things. So the name needs to be neutral, because I need to understand that can be reused for any other feature. So let's say, for example, forms. Let's say I have a specific style in all my application where I'd like the form to look the same in terms of styling, in terms of, colors, headers, whatever, like the structure of it. Then I wouldn't have, a folder within my organism, which would contain the logic of the form under the name of the feature. I would say organism, form manager as a folder. And I say manager because, again, inside of the organism, it's not just the UI. You're going to use the UI, the style that you're doing in the atoms and molecules. But really what the organism is, it's a manager. It manages everything that needs to happen. And so, for forms, there's so much that needs to be handled. For example, form validation is one of them. You don't want to do form validation in molecules, which is a group of atoms, or in the atoms, which is just one simple UI element. So you may want to do the form validation at the organism level. And again, like this kind of things, for example, forms, is not just tied by one feature. I'm reusing the same form folder, form manager, across different features which have nothing to do with each other. I'm just passing different set of data from the page level. Okay. I hope that answers your question.
Thanks for the explanation. And then the now really last question from Candida. What version of TypeScript is suitable to front-end developers, beginners? So maybe is there any difference in with what version to start? Or
Yeah, so there's been quite a few different versions of TypeScript in the past. When I started using TypeScript 2 years ago, there was a huge breaking change in their newest version, which kind of made that a lot of code which I had just learned, not a lot, but some of the code which I had learned, which to me at the time looked overwhelming because I had just learned it, was not applicable really anymore or was not modern. I would always use the latest table. Because usually there's always a good reason why they made the change. And, it may look a bit cryptic when you look at it, but it does make your life easier. So that means that, you will have to spend initially a bit more time learning it, but then after that, you're going to go way faster and you're going to write better code. So I would try to do the latest version. And the changes that they have between version is not so bad that it's a completely different language. Like the things which developers, which are beginners, will use will probably be the same across versions. The only thing you'll use is types, like defining your props in types and interfaces, so that when you type your props in your component, you're going to see the highlights of what's expected. And that doesn't change between versions. The things that change between versions are generally way more advanced. And, as a beginner, you won't really be that much concerned.
Okay, so Nathalia, that was the last question. Thank you so much for this talk. It was very interesting. I'm sure that a lot of people can take something from it. So I hope to see you in person at some physical event in the future.
Definitely. Yeah, definitely. Thank you for your questions as well. And I do remember that I will share my slider to social media.
Perfect. So nice greetings to London from Vienna. And for everyone else, we have our next talk lined up and it starts in 6 minutes. So also with TypeScript and Vue.js working together like peanut butter and jelly. Looking forward to that one, delivered by Richardson. So see you in a couple of minutes again. Hello everyone, hello back again, and hello Rob, how are you?
I'm doing well, how are you?
Good, good. Where are you joining us from?
I'm from Phoenix, Arizona.
Wow, and what's the time there?
It's 8 a.m. this morning.
Okay, did you have your breakfast already and coffee and everything?
I did. And now I get to time travel into the afternoon. How's this afternoon gonna look for me? How's this afternoon for you?
I hope that it will be a cool and fun session with you. I'm sure. So I watched some other talks. So pretty exciting. And tell us maybe briefly what will we learn from you today.
Sure. Today we're going to look at Vue and TypeScript. We'll do a quick level set. This isn't a 101 talk for Vue or TypeScript, but we'll get to look at both of them, and then we'll get to add them together, starting out from a basic and then looking at ways that we can include JavaScript libraries in TypeScript projects. So we'll look at half a dozen techniques of mechanisms to be able to do that, from libraries that were built with TypeScript to libraries that have TypeScript bindings added to them, to libraries that were never invented to have TypeScript with them. I'm really excited because we'll get to dig into all these things, and you'll leave with the GitHub repo that we talk about today so that you can both replicate these demos and try out each of these experiences on your own too.
Okay, that sounds fun. Rob, the stage is yours.
Welcome everyone to Vue and TypeScript, working together like peanut butter and jelly. I really enjoy this talk. It is so much fun. It will mostly be live demos. And so let's jump in. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. You may go look tonight, tomorrow. I've been that guy chasing the speaker. I chased him for a few months. And at the end of the day, I never got the slides, which is why you can go to robrich.org right now and you can see the slides. Let's go there. If I go to robrich.org and click on presentations, here's Vue.js and TypeScript working together like peanut butter and jelly. Here's the slides and here's the code. They are online right now. You can get at this code. You can replicate the demos. You can fast forward through the slides. They are online right now. While you're here on robrich.org, let's click on About Me and learn some of the things that I've done recently. I'm a Microsoft MVP. I'm a friend of Redgate. I'm a single store developer evangelist. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building them free software Friday after work. Sunday afternoon, we deliver completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Vienna or wherever you're connecting from, hit me up on email and Twitter, and let's see if we can get a GiveCamp installed in your neighborhood too. Some of the other things that I've done, I worked on Gulp as a core contributor in version 2 and version 3. And one thing I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into Vue and TypeScript. When we're looking at Vue and TypeScript, let's look at each one separately. This definitely is not a Vue and TypeScript 101 talk, but let's look at what makes them ideal for their suited applications and how we can combine them together to use the best of both of them. So what is Vue? Well, it's a SPA framework, not that unlike Angular and React. It focuses on developer productivity and easy learning. Taking a step back, React, Angular, and Vue, there really is not a bad choice here. All of them have a virtual DOM, a component-based approach. They use Babel and Webpack to transpile and bundle things. They output HTML, CSS, and JavaScript for use in the browser. And they all have a rich ecosystem of plugins. So you can leverage the power of the community to build up your content in really elegant ways. Ultimately, there is no wrong choice here. If your preferences differ than mine, then by all means, jump in and build excellent software. React, Vue, and Angular. So where are they different? Well, Angular requires TypeScript. And you really can't begin with Angular unless you're working in TypeScript. Yes, technically you can do it in JavaScript, but it really isn't a great experience. By comparison, React has JSX. JSX mixes HTML and JavaScript in the same thing so that you can separate your components not by technology, but by business process or by user experience. Vue has single file components. Like other mechanisms, you have a mechanism for keeping all of your CSS, HTML, and JavaScript together. But unlike other approaches, they're all in their specific format. I'll build HTML in HTML, and I'll build JavaScript in JavaScript. I'll build CSS in CSS with CSS style sheets. But they're all together in one file, and I'll transpile those with Babel and Webpack to get at my bundles. So my completely biased opinion, Angular is built for tooling. Angular makes IntelliSense work really well, static analysis work really well. Facebook really pioneered React, and so React is really good at those really heady, really intense concerns that Facebook has. By comparison, Vue is built for developers and really focuses on keeping the concept count low and making the on-ramp really easily. If you grab these slides from robrich.org, you can click here through to the blue links and learn more about the difference between React, Vue, and Angular. But again, ultimately, there is no wrong choice here. And so if you've chosen one and you really enjoy it, then continue building spot applications with your choice. It is a great choice. So how do we get started with Vue? Well, we can say Vue create my app. I've done that here where I say Vue create my app. And once I've done that, then we'll get to be able to pick through the things. So I'm going to say manually select features. Now I'd like to use Babel. I can turn on TypeScript. I can turn on progressive web app support. I can use Vue router. I can use Vuex, the Flux store. I can use CSS preprocessors like less or Sass, turn on linter and formatting, pick unit tests with Jest or with Mocha and Chai, end-to-end testing with Cypress. And then once I've done that, now it will interview me to be able to pick other details associated with my application. And so I can walk through this mechanism to get started with a Vue app. Now I'm not going to fill this out because let's jump into a different app, but that's the mechanism of getting started with Vue. Once I've created my app, I'll npm install, I'll npm run serve, and now I have my app running. That's the mechanism of getting started with Vue. Now let's look at TypeScript. It's definitely not a TypeScript 101 talk, but what does TypeScript bring to the table? Why would we choose to include it? TypeScript is great at answering the question, did I call it correctly? Let's look at this fictitious line of code that I found in an application somewhere. I'm calling some critical function. I'm passing in a customer and an invoice, a date. Okay, all this makes sense. Now I'm passing in true. Why do I have curly braces around that? What is the value of true? Why is it true and not false? Then I'm passing in false. What is false? Is that a configuration thing? Am I opting out of some functionality? And then why do I have 2 commas here? Was that a typo? Am I passing in undefined as my next argument on purpose? What is 6? Why is it 6? Did I call this function correctly? I don't know. I need to open up the next file, take a look at that file, see what its interface is, see what all the parameters are, maybe look through the method and understand how it's called. I really need to get deep into the abstraction to be able to understand, did I even call this function correctly? And so similarly, it's difficult for us to find bugs or to experience if we've done this without a whole lot of tests and maybe some manual testing. My inner loop is pretty slow. Here's a way that we've started to solve it in the past where we pass in this configuration object. So I'm going to spread out all of the objects. I'm going to build a customer, invoice, date, and config. Now I know that I have 4 parameters, and I know that I need to pass them with these names. I'm passing in this object, and maybe inside that function, it'll spread those right back out so that we get that object. Now that's a good option of starting to get a little bit more descriptive, but let's level up some more. Here's another great example of did I call it correctly? Now this one's from jQuery. In jQuery, I can select things and then I can do actions like change their CSS or hook up click events. And jQuery also has an AJAX function where I can go call external services and get inline values. Should I have selected an object and then called AJAX? Or is AJAX a function just on the dollar object and not on a selection? I don't know. And there isn't a great way to figure that out. Let's upgrade to TypeScript and see if we can find some ways to understand our typos and correct that faster. TypeScript is a superset of JavaScript. All valid JavaScript is valid TypeScript. It adds optional type hints at design time. And at design time, I can now use these type hints to understand if I've called this function correctly. It doesn't validate runtime behavior. What runs in the browser is JavaScript. But it compiles to JavaScript, and that's what runs in the browser. I'm not running my TypeScript in the browser. I'm only using TypeScript in my editor to be able to get design time hints to understand if I've called this function correctly. TypeScript is free and open source, and I can install it from NPM. So TypeScript, it's like Babel, where I can use new features of JavaScript sooner. For example, here's features that came to TypeScript before they came to browsers. The optional chaining, where I have question mark dot, that came to TypeScript and was part of TypeScript before it was ratified and included in JavaScript. Similarly, the nullish coalescing operator was part of TypeScript. So TypeScript will transpile back to regular JavaScript and perhaps to a lower version of JavaScript. I can definitely control that. Private fields is another great example of a thing that came to TypeScript first. Now, in the case of private fields, when the final JavaScript syntax came out, it was a little different. And so TypeScript did need to modify to be able to be a complete superset of JavaScript. Now you can do private fields the JavaScript way or the old TypeScript way. TypeScript, it validates that your types match. It doesn't validate your business logic. Now that's a key distinction, because if you're using TypeScript to be your only unit test, then it's not a great fit. You should still do a lot of testing. How do we get started with TypeScript? Well, the first thing that we do is we create we rename our files from .js to .ts. So I'm going to rename this file from .js to .ts, and now it is a TypeScript file. I'll also rig up my TypeScript compiler. Next thing, I can optionally choose to add these design time hints. Now, in this case, I have a function that takes in a name and returns this phrase. I'm going to annotate this to say it takes in a string and it returns a string. Now, these are optional, but now that I've expressed my intent, anyone calling my function will get red squiggles if they're passing in something different, like a number or an object. That's great. Now they can tighten their inner loop to be able to find that typo faster. Let's take another example. Now I've already renamed my file from app.js to app.ts, and I have this line in my source code. X equals some object. A is B and C is D. Did I call this correctly? Did I name my parameters the way I needed to? I don't know. Let's add optional type hints. In my types.ts file, I export an interface called customer info. I already have more information. This is a customer related thing. Now here in customer info, I have A, it's a string, C is a number, and O is a string. But notice this question mark. This question mark notes that it is an optional property. Okay, now that I have this interface, let's import customer info from types. And now we'll declare this object, this customer info object, using A as B and C as D. Here we've given it that optional type hint. Now what we can see is we'll have red squiggles under this D because, well, C is supposed to be a number, and right now C is a string. So I'll get that information. Now that was great. I got this type hint while I was building my source code, so now I can adjust this. But now will my bundle size be bigger because I'm including another file? Well, these are only design time hints. So when this TypeScript gets transpiled into JavaScript, this whole import will go away. I won't have an increased file size just because I pulled in this type hint. That's really cool. TypeScript was able to help us figure out where we call things correctly and help us validate that the types are as we expect. Now, here's a pro tip. Often TypeScript can figure out the types itself, and that's wonderful when you're just getting started with TypeScript. But it's great to make your intentions clear. And so whenever you can, add the optional type hints so that you can explain what's going on here. Now, maybe TypeScript will figure it out, but maybe TypeScript will guess wrong. And if you can explain your intent, then maybe the developer coming behind you will be able to understand this. Now, often when I'm coding, the developer coming behind me is me. Shortly after I forgot why I did this. And so leaving myself clues allows me to get back into the code base faster. So we've looked at Vue and we've looked at TypeScript. Let's see what it takes to put them together. Now let's take a look at this application. We started out by saying, let's go create an application. And I've created that application and here it is. Now I have this tsconfig, and this tsconfig defines how my type It looks like I may have fallen off the call. Where did I jump off? Well, let's jump back in. So here's my Vue and TypeScript project together. I've got my tsconfig, and that describes how I'm going to build up my application. I didn't need to type any of this. As we created the application here, all of that content was built for us. Here's that tsconfig, and now we've got our transpiled solution. Here's main. Now, Vue has great components. So here's my about component, and it's just going to tell me that I've got an about page. Here's my home component, and my home component will actually include this hello world component. Here's my script section where we can talk about the content that's pulled in through this component. If we go look at that component, here's my, and I've got my HTML in the HTML spot. I've got my TypeScript in the TypeScript spot, and I've got CSS styles in my CSS spot. Now notice that these ones are scoped. Scoped meaning that these will only apply to this component and don't get these styles leaking into other parts of my application. Notice that I've opted to make this TypeScript by saying script lang equals TS. Now that's perfect. I've got my application ready to go. Now here in, not that one, here in GitHub, we can see the, let's not do that. Let's go here. Here in GitHub, the application, the source code for this application, we can see various steps associated with this project. Here's step 0, where we just created our application. Now I'm going to build up step 1. I just did a few ESLint fixes to make sure that this will work okay. Step 1. And so here in step 1, I'm just making sure that I've got consistent semicolons, just doing all of the small fixes. Okay, now that I've got step 1 in place, I want to go start including some components. Let's start by including Vuetify. Now, Vuetify is a really elegant design library that allows us to do material design. So let's do that. We create our app and we cd into our app and we say Vue add Vuetify. So I've done that here. Let's step into step 2. And I've got my application ready to go. Now it's already serving, so let's go rebuild the application. But if we pull in our app main.ts, now we see that we've imported Vuetify from this plugins Vuetify, and we have here in plugins the Vuetify plugin. But well, TypeScript knows nothing of Vuetify. This was a library created before TypeScript was a thing. So how do we include Vuetify in our TypeScript project? Well, Googling a little bit, I found this, this article that describes that I need to specify the types coming in here, and I need to add the types. So let's do that and pull in this fix. 03. Okay, so now our app is rebuilding. Okay, we've got some, now look, we've got Vuetify, and TypeScript knows exactly how to build this. Now, I did get some errors here because I need to rebuild my app rather than just refresh it. But if we come here to localhost 8080, let's go look at this app. And now we've got some Vuetify content in place. Oh, looks like I definitely do need to restart my compiler. Okay, npm run serve. It's going to transpile it in memory, but now we've got Vuetify in place. Okay, so let's give that a second to rebuild. Building. I love when I'm watching this sometimes because I notice that both numbers go up. We'll get the number of modules going up as it discovers new references. And then we'll also get the number that we built jumping up so that we can transpile each of those things. Now, I could have pulled in just the Vuetify components that I need, and my bundle size would definitely be a lot smaller. But in this case, I just took the easy route and pulled in all of Vuetify. Almost there, almost there. Okay, now we've got it. Okay, so let's refresh our application, and now we have Vuetify in place. All this material design, that works out really well. Great. I love that we've got this JavaScript library included in this TypeScript project. So let's start pulling in some components. Now I want to pull in, let's build a counter component. Now this counter component is pretty interesting. I have just a regular component here. I have here the markup that will allow me to build this component. Here we're using regular handlebar syntax to be able to grab the value of this count. And here we have an @ sign listening to the click event of this button, calling the add function and the subtract function. So here in my component, here's my default value. It'll start with 0. And I have my add component, or my add method and subtract method that is adding and removing one from my count. Pulling up this page, I've created a new view called Playground. And here in Playground, I can increment and decrement my content to be able to get at what I need to. I am exporting events so that my calling app can also understand the count. That's cool. We've got our component in place. Let's add some more components. Now, because these components were written in TypeScript, then there's no difficulty at being able to do all of the pieces. Now I've got some more components, but I did make a mistake here. Now I'm emitting the count changed event and I'm specifying the count. But here in my Playground, I'm pulling in that counter component and listening to the count changed event and calling my count changed method. Here in my count changed method, I thought count was a string. Now it's not a string, it's a number, but as the TypeScript gets transpiled to JavaScript, that string, that JavaScript has no concept of types. And so you see that my component works just fine. Now it is a number coming across, but it works great. Now I built some other components. Here's a component using font awesome. Here's a navigator component. Here in my navigator component, I wanted to look at how can I link using either Vue router directly or link programmatically using this navigate method. So if I'm here on my navigator, I can link and come back to Playground, and I can link programmatically as well. Now that was cool. Here in our TypeScript, we see that it understands what $router is. Vue just understands that Vue router is a thing, and so we get TypeScript support straight away with Vue router. That's cool. We've got some more libraries in place. Now let's take a look at the next piece. So I have some I'm looking through this Vuetify piece, and I really like this form. I like this form component because, well, it'll validate, it'll tell me that my name is required and my email is required, and it'll validate the email format. I still can't submit until I select all the things, and now I can submit my form. Okay, so let's come into the code. Let's grab this template code, the JavaScript code, and inside of our application, here's that form component. We've got our markdown, our HTML here referencing all of the vForm components and vText field components. We've got our JavaScript in place, all of our validation functions, and now we're getting an error here because this form is, well, either a view or an element or a view array or an element array, and Vue doesn't know that that has a reset function on it. Now we can go, so how do we fix this? This is a mechanism where this JavaScript library was not supported in TypeScript. Let's take a look at a mechanism that we can use to be able to build that. Let's say here in our computed section, we will have a control called form. Now form, we will return this $refs.form as HTML form control. HTML form element. Yeah, as HTML form element. And we'll also say that this form will return that HTML form element. Now in all of the places that we said $refs.form, let's just call $form directly. We've created this extra mechanism, and now we get HTML support, TypeScript support in calling each of these methods. Now in time, maybe we want to separate this into a separate interface, but here's our first technique of being able to include JavaScript projects and TypeScript projects. We can cast things as the content that we want it to be. And now when consuming that app, control, that value, then we have the proper interface attached to it. Now, as does tell TypeScript, hey, I got it. I know what this is. So TypeScript isn't going to say, well, is that actually a thing? Do I need to strip properties off of it? Nope, it will just make the TypeScript compiler understand that we think that thing will be that way. So we've got this. Let's separate that out into a separate library. And so now, rather than, now we've built this vForm type here in types. We have a, not there, views. Where'd we go? A form. We have this vForm type, and this vForm type is pulled in from types. Let's come in here to types, and we can see that we have this vForm type. Now, this vForm type is an HTML form element, and it's a component, and it has this very specific interface. Because we've defined that interface here in TypeScript, we now know exactly what methods we'll be able to call on vForm. So we cast this ref to a vForm, and now we can call all of the methods on that form. Great. We were able to use as and cast it to a new type. And we also started taking a look at building our own type definitions. Let's come back to that. What we can see now in our application is that we've got this form, and it now works correctly. Once I pick all the things, my submit button will light up, and now I can take action. Perfect. Now I'm enjoying this mechanism, but I noticed that my counter component always starts with 0. I want to take the next step, and let's see if we can make it start with a random value. Now, Lodash is a really great power library that includes lots of functions. Now, in most cases, browsers have caught up, so maybe I can use a native browser function. But if I go search for random here, I get this random function, and it takes in a lower and an upper. So let's include that. Let me come to my counter component, and I will say I want to import random from Lodash. TypeScript knows nothing of Lodash. Lodash is a library created without TypeScript bindings. But now I'm going to say random 0, 100. Okay, now the JavaScript that this outputs will work just fine. We can see as we're building, everything works great. We have a lint error, but in our application, it works just fine. Here it started with 17, now it started with 93. Now, how do we get TypeScript to understand how Lodash works? Well, let's create a new file, and we will call this lodash.d.ts. This is a type declaration file. We are going to say declare module Lodash, and Lodash has this functionality. Now, notice that we're not importing it. We're just referencing it with the exact same name. Now, I do need to restart my transpiler. I do need to restart VS Code to get the TypeScript to restart. But once we've got that in place, now TypeScript understands that Lodash is a module. Now, it knows that Lodash is a module. I didn't need to import a declaration. I just have a .d.ts file in place. It doesn't yet know what this random method is. Okay, so let's tell it what random is. Random is a thing that takes in a min, and it is a number, and it takes in a max, and it is a number, and it returns a number. Now that we have this random function defined, now if we come back here into counter, now we get no squiggles anywhere. Perfect. Now, if I were to pass in something that isn't a number, I'm getting those red squiggles. Or if I pass in only one argument instead of two, I get those red squiggles. That's cool. In our transpiled JavaScript, it still works just fine. We've got our, oh, I may be racing the compiler here. Yep, there we go. We still have our application. It still works just fine in JavaScript, but now TypeScript works as well. Here's another technique. We created our type declaration file. Now here in this type declaration file, we described this one method that we're using, but there's a lot to Lodash. There's this one, I didn't even talk about the floating piece here. And there's a lot of libraries inside Lodash. It would take a while for me to document each of these. Now, if I were to document these, I might want to publish these into the open as an open source project. And that's where definitely typed comes in. Let's look at another technique. Definitely typed is that collection of open source libraries. And you see it's truncated to 1,000 files, but there's 6,500 libraries in this repository. Inside here is not the JavaScript that accomplishes the function, but just the type declaration. And each of these folders are now published on NPM as types/that package. So if I go search for types/Lodash, I'll land on this page that gives me all of the type declarations for the TypeScript, for the JavaScript library. Now, Lodash was still not designed with TypeScript in mind, but Lodash does have type declarations here definitely through the definitely typed project. So usually as I'm installing a library, I will start off by saying npm install my app, and then I'll come right back around and say npm install --save-dev at types/my app. Now that will go grab the TypeScript declarations for this particular library. Now, if there aren't type declarations, that's okay, but that's kind of the easy button. Let's go get the community's type definitions in place. So I definitely created a lodash.d.ts, but I could have just imported at types/lodash and gotten that lodash.d.ts with all of the definitions, including the optional parameters I didn't define. Definitely typed is a great way of doing that. Okay, let's level up again and start looking at another mechanism. 08, I think demo, I think I live coded that one. 09 is where we pull in that type declaration. And let's look at this. So I'm really enjoying how this project is working. I'm getting some great components. I want to look at adding some more components. Now, one pro tip is if you're looking for things, Google for awesome and that library, and you'll probably land on a library on a GitHub repo like this. Here's awesome Vue. Here's a list of curated components that talk about really cool things. And I'm still just in the index. Here's the content for this. So I went here and I said, I want to look for a parallax library. I really like that parallax technique. Okay, so looking through these parallax libraries, I think I'll use Vue parallax.js. Here's Vue parallax.js. Now I've pulled in Vue parallax.js and imported it in the way that my thing, oh, hey, TypeScript knows nothing of Vue parallax.js. It was a library built without TypeScript support. So now what? Well, let's go look through this library and say, well, how do I build a type declaration from this? Okay, export default. That seems a little bit better. Install. Okay, I know that there are various applications that install, and so maybe I can go reference other type declarations. This takes in a view. I know what a view is. OS. What is this OS? I don't know. So can we generate a type declaration file? Yes. Let's step up to this, Stack Overflow post that identifies ways that we can define type declaration files. TSC is the TypeScript compiler. And if we pass in a TypeScript file and we pass in -- declaration, then it will generate a TypeScript declaration file for us. Now, it may not be perfect, but let's try it. So we're here in that Vue parallax folder. Here's our source code. It's .js. And we are using the, I think we're using this one. Nope, we're using this one. So let's start off by copying that from JavaScript to TypeScript. Now, all valid JavaScript is valid TypeScript. So now that's a TypeScript file. Now we can say tsc -- declaration Vue parallax JS, and we'll give it the TS file, and it's going to build for us this, this TypeScript declaration. Now it has some problems, but if we pop open this file inside of our editor, that will definitely get us started. Here's that .d.ts file. So it said, here's this install, and it takes in an any, and it returns a void. We've definitely gotten past stuck. That's really cool. So let's take that. I'm going to go delete this one and this one just so they don't get confused. And let's pull in the solution, the TypeScript declaration file that I was able to craft. So I did move that Vue parallax.d.ts file here and used this together with some other TypeScript declaration files for Vue plugins to be able to build out this experience. I know this is a plugin with Vue parallax.js options. And so now back in my main.ts, we can see that Vue parallax worked just fine. TypeScript understands how it works. When we're building our app now understands how it works. And so here in our app, now we have this parallax experience. You can see how this background moves slower than this foreground. That's cool. So we saw a bunch of techniques of including JavaScript libraries in a TypeScript project. Vue was great to be able to give us that experience, that rapid runtime experience. And I love that it builds up those components slowly. Here's a list of all of the techniques that we explored and a few more. Now, this isn't in the order that we discovered them, but rather here's in the order that we should prioritize them. Grab these slides from robrich.org and you'll get this exact list. So to start off, use the libraries built in TypeScript. Now, you're probably not choosing a library based on what language it was written in. So if all else is equal, a TypeScript library is perfect. But if all else is not equal, then let's keep moving. Install @type/your library. Definitely Typed is a great way to be able to pull in community definitions of these type declarations. Now that will probably get you solved, but in some cases that won't. Maybe there isn't a type declaration. At that point, we can handcraft a declaration file. We saw how we did this with Lodash, how we built up that lodash.d.ts. We defined the module, the methods and properties that we needed, and that then became our TypeScript declaration. We can generate a declaration file. We saw how we did this with Parallax.js, where it got us started. Now, maybe that's not perfect, but that together with other TypeScript declaration files for similar products will help us to craft a declaration file. Once we're done, it would be great for us to publish this to the open, either as part of Definitely Typed or as part of the module that created that. We also saw how we could use as to be able to cast something into the type that we knew that it was, in spite of the fact that maybe TypeScript didn't guess very well. Next up, we can use as any. Now, any is a mechanism inside TypeScript that says, I don't know what type it is. Now, that's totally fine if it's a really, really hard type to describe, but we're kind of giving up here. We're saying TypeScript, just don't help me. Well, why did we opt into TypeScript if we're just going to tell TypeScript to ignore stuff? And so there is a mechanism in ESLint to be able to look for any and to be able to bar that. Here's another one where we can create this @ts-ignore. Now, this is a comment, but TypeScript will see that comment and ignore the type declaration, the code in the next line. So it won't validate the types of that next line. Now, that's great if it's just a really complex thing that you can't figure out, but I would use this as a last resort. There is an ESLint mechanism to ignore this as well. So here's that mechanism. Use TypeScript libraries, use Definitely Typed, craft a declaration file, generate a declaration file, use as to cast it into the type that you want, use as to cast it into any if you can't define it, and use ts-ignore. These are all techniques that you can use to include JavaScript libraries in TypeScript. When would you use TypeScript together with Vue? For a long-lived project. If you want to communicate better between your developers, and it's good for that first check of your syntax. When would you want to avoid TypeScript and Vue? Well, if you depend on a lot of components that don't have type declarations that were not built with TypeScript in mind, you may spend a significant amount of your development time crafting those interfaces for those libraries. It may not be worth it. In that case, it may be easier to just move with JavaScript and keep track of the types yourself. If you're doing a quick doodle or you're starting a project that doesn't use the CLI, then you really can't use TypeScript. TypeScript does require that bundling and compilation process. So if you just have a Vue script tag in your page, then yeah, you're crafting JavaScript. But I love that Vue is approachable in that way. And if you believe that TypeScript is your one and only unit test, then TypeScript is probably not a good choice. You're using it as a crutch. You still need tests that validate your logic. TypeScript will validate your syntax. It will not validate your logic. Jeff Fritz is one of the core contributors to Vue, and Jeff has some thoughts on TypeScript. He built the enterprise boilerplate, and the enterprise boilerplate is a great quick start to get started with large-scale Vue apps, and it was originally written in TypeScript, and now the TypeScript has been removed. Click through this blue link from the slides at robrich.org to understand Jeff's thoughts and why he doesn't recommend TypeScript right now. Spoiler, has to do with lots of component libraries. In time, as we move to Vue 3, hopefully we can get a whole lot more TypeScript support in a lot of our libraries. This has been a great tour through Vue and through TypeScript. I think it is a really elegant solution for large-scale applications when you need to express your intent and communicate between developers. We looked at a bunch of strategies of how to get started with Vue and how to get started with TypeScript, and in particular, to include libraries that weren't crafted with TypeScript in mind. You can definitely pull in JavaScript libraries into your TypeScript project. It's been a lot of fun. Grab the slides at robrich.org and grab the code here at GitHub, and you can replicate all of these demos at each step. For those who are watching this project later, you can grab me at rob_rich on Twitter. For those who are here live in the conference, what are your thoughts and questions?
Okay, Rob, thank you very much. That was a very nice overview with some great advices. So let's jump right into the questions and comments. There is quite a few, so let's see which one to use first. Okay, let's take this one. So how would you compare TypeScript to Flow or JSDoc?
I've not used Flow, but JSDoc is a great way to be able to declare how the method is used, and it's a great way to explain that to consumers. But it doesn't do any runtime checking, so you still have to click from where your code calls into that function declaration to be able to see the JSDoc comments. Now, depending on your editor, you might have a mouse over experience to be able to see that declaration, so maybe it's starting to help a little bit. TypeScript takes it to that next level and says, I'm going to go validate that you did call it correctly. You may choose to include JSDoc and TypeScript together to be able to get that definition and also to be able to validate that you used it correctly. That might be a really great idea. Presuming that Flow is similar, then maybe Flow gives you that ability to document your methods as well. I now have some homework to go understand Flow.
Okay, let's go to the next one. Do you prefer this component style over class style TypeScript components?
Good question. That was one of the interview questions that they asked us when we were first scaffolding the projects, is did we want to use class style components? And I said no. Class style components was a great experiment inside of Vue to see if classes would be an elegant way to describe that. React and Angular both had class style components as their native experience. But React is starting to move towards functional components with hooks, and Vue is no exception. It's moving in that direction as well. A class was a good experiment, but in the long term, maybe functional style components will be a better fit. We'll see. You know, it may turn out that classes are where we return to, but knowing that the JavaScript community is moving away from class style components, as I create a TypeScript project, I also move away from class style components. Now, if you have an existing class style component project, then it's not deprecated. You may still continue with that, but going forward, you may find more success in functional based components instead.
Okay, perfect. And then another question, maybe it's related. So does this work with composition API components?
Yes. Composition API components are a new thing in Vue 3, and TypeScript and Composition API works out really, really well.
Okay.
Part of the Composition API is that you get less defined things and more just building the content as you go. And so I find it a little bit weird, but once you wrap your head around the component API, it's pretty cool. Vue 3 was written in TypeScript, so you'll also get much better TypeScript support from both Vue and components that are set to work with the Composition API and with Vue 3. It's a really elegant move.
Okay, another related question, a general one. Does this only work with Vue from version 3?
TypeScript was built in, Vue 3 rather, was built in TypeScript. So the TypeScript support in Vue 3 is phenomenal. All of the demos I did were in Vue 2. And so yes, you can use Vue 2 with TypeScript as well.
Okay, but it's more of a hack, right? In comparison, if you would have Vue 3?
It was an afterthought. So there are parts where you'll bump into sharp edges. But in this case, it worked out just fine.
Okay, perfect. And then, okay, then there is a provocative question. If you want to answer it, you can. If you don't want, then don't. Then what are the reasons to use TypeScript? I'm still not convinced, smiley.
Yes. The reason to use TypeScript is to get those type checks in your source code. Now, yes, it does take a little bit more to be able to do stuff, but as you're starting to define your code, those type definitions will allow you to check to see if you've called the method correctly as you're typing the method. Now that's really, really handy because it speeds my inner loop. I no longer need to create these mechanisms of passing in objects or starting to craft args things to be able to guess if I've called it correctly. TypeScript will validate as I'm typing my code if I've typed it correctly. Now this is syntax checking, not logic checking, but that's why I love TypeScript, because it will syntax check as I'm typing, a really, really fast inner loop. If you value that skill, TypeScript can be an elegant solution. If you don't need that, then stick with JavaScript. It can work just fine.
Okay, next question. I read it. Vue is cool, TypeScript is cool, you are cool, but why do you use Windows?
I love that question. That is so wonderful. Why do
you
I
have
use
a reason
Windows?
for that? An answer for that?
A lot of developers use Macs just because, Linux, containers, it feels more native that way. I grew up on Windows building C# apps. And so as I moved into Node, my Windows PC was just the way to do it. I do hit some sharp edges building Windows apps, but now that I've got containers and I can spin up Linux containers on my Windows machine, it works just fine. It is a jab that I get often though, so yeah, thanks for jabbing me. All else being equal though, you could find similar sharp edges on Mac. Containers work in a virtual machine on Mac just as they do on Windows. Really, if you want to get closer to the metal, a Linux machine, an Ubuntu machine is really the best way to get there. The unfortunate part though is that machines don't usually come pre-installed with Ubuntu, and the driver support for games and other apps really isn't there. So if it's only a development machine, maybe a Linux machine is perfect. But if you need to also do other stuff, then choosing a different type of machine may be an ideal choice. My preference is Windows, but your preference may be different, and that's completely fine. You can be successful in Vue and TypeScript on a Mac, on Linux, on Windows, on a Raspberry Pi, or whatever device that you'd like.
Wow, that's so cool. I mean, rarely I hear such a diplomatic answer on this topic. So what else do we have? Yeah, is there any specific editor you recommend for TypeScript and Vue? I saw you are using Visual Studio Code, right?
I was using VS Code, and VS Code does have the TypeScript bits kind of built in. TypeScript and VS Code are both built by Microsoft, and so there's great support there. There is decent support in other editors. I've used WebStorm with TypeScript and done okay. If you have a favorite editor, I'm confident you can get TypeScript support in there as well. If your editor doesn't support TypeScript, you still get TypeScript support on the command line. So we saw as I pulled up the console that I would get those TypeScript warnings there, and I can use that to get straight back to the source code to see what failed. If your editor does support TypeScript, then you'll get it in line as you type, and that is so cool to be able to get support for, or to get syntax checking as I'm typing. That allows me to be much faster on my inner loop.
Okay, and then last question, but it's a quick one. Is TypeScript similar to Golang? I would say no, not at all, actually.
It is kind of similar and kind of different. Golang is very specifically geared towards Google's problems of ensuring that all of the syntax between applications is identical. so that anyone in Google can pick up with an application and continue on. To that end, Golang rather, treats syntax as errors. So unless you have a linter running behind the scenes to make sure that your Golang has exactly the right spaces and carriage returns between it, then you'll get errors in your Golang process. By comparison, TypeScript is a little bit more forgiving there. It is explaining types. And so if you're familiar with Java or C# or other languages that use types, you may be right at home in TypeScript. It isn't quite as authoritarian as Go is, but that is a good comparison, and I like that comparison. If you're coming from JavaScript, TypeScript's types may feel a little bit more draconian than you expect.
Okay, so this was already the last question. I would ask the audience to rate the session also in the Q&A tool. And Rob, I have to say thank you so much. It was really fun. It was very interesting. I think everyone enjoys your presentation style also. And I hope that you at some point also can travel over to us in Europe to join one of our physical conferences in the future. So thank you again.
Most definitely. I'd love to join you here at this conference or in another event that you're hosting once we can move around again. Exactly. Thanks for having me. This was so much fun.
Perfect. Greetings to Arizona. Bye-bye.
Bye-bye.
Okay, we are again going in a very short break, 3 or 4 minutes, and then we have the next session lined up. And yeah, so see you in a couple of minutes again.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Okay, welcome back to our last session of today. I am here with Kirsty. Hi.
Hello.
How are you doing?
I'm very good, thank you. How are you?
Good, good. And where are you joining us from?
I am joining from Shropshire in the UK.
Okay, we heard from Nathalia that in London we have nice weather. Do you also have nice weather in the Midlands?
I do, yes. Yes, it's very unusual in the UK.
Okay, then enjoy it as long as you have it. And tell us, what will we learn from you today?
So I am going to talk about CSS Grid and all the cool things well, not all, but some of the cool things you can do with it, and also cover off some of the things that people tend to trip up on.
Perfect.
Hopefully you will find it excellent.
Looking forward to that one. Yeah, the stage is yours.
Okay, thank you. Hello. So in this session, I'm going to cover some of the concepts of CSS Grid. I'm going to show you some examples of how it can be used and cover off some of the gotchas as well. Throughout this talk, I've got lots of examples. I've added all of them to a CodePen collection, which I've also linked to in the slides, so you can have a look for yourself later as well. You will notice that some of this is themed using the film Bill and Ted's Excellent Adventure. Don't worry, you don't have to have seen the film to understand CSS Grid. But first, a very small amount about me. So I work as WordPress engineer and front-end developer for HumanMade, who are a global agency and makers of Altis, our digital experience platform. I live in Shropshire in the UK with my wife. I have 3 cats and 2 house rabbits. If you want to chat to me at all, you can find me as @KirstyBurgoyne on all the social media. If you're interested in pictures of fluffy rabbits, I suggest you find me on Instagram. But let's get started. And we'll start with a small bit of history. So in the beginning, we had table layouts. There was so much HTML everywhere. We used things like spacer GIFs and graphics for rounded corners. It wasn't good. Then we made it worse by using frames, where we would then add all of our table layouts, so there was at least 3 times the amount of code. But there was light at the end of the tunnel, and it was CSS. For me, this enlightenment came from reading Dan Cederholm's book, this one. I learned so much about CSS from this book. This is obviously going back quite a long way, so it covered things like how to use floats and display properties to create much more semantic, accessible, and SEO-friendly layouts with far less code. And this really was a game changer, not just for me, but for the whole industry. After that, we saw the sites like CSS Garden pop up. And they really showed how you can style a page without ever needing to change the markup. Since then, more and more features have been added to CSS. Browsers have moved on, and eventually even support for IE6 ended as well. Today, we now have CSS 3, and this gives us a lot more layout options. So here we have display block, display flex, and now display grid as well. And there are a few others available as well. Each of these has pretty good support. These figures were taken around about a month ago, but they're still they've barely changed. So display block has been around for a long time, has 100% support in all browsers. Display flex has nearly 99, and display grid has 94.47. And this means that if we take the approach of progressive enhancement, we can create flexible and scalable layouts for all browsers and devices. So let's start talking about what CSS Grid is all about. And MDN web docs define it as a grid is an intersecting set of horizontal and vertical lines, one set defining columns and the other rows. Elements can be placed onto the grid within these columns or row lines. And this neatly sums this up, I think. These intersecting lines create a 2-dimensional grid system, and this makes it the first true layout method to be introduced to CSS. It differs from other layout methods because they're all 1-dimensional. Grid gives us the ability to control both row and column properties together, and the flexibility to present content across devices in a way that we've never had before. So we'll start by making a grid. And we will start with an implicit grid. If we take this container of 5 items inside of it, and then apply display grid to it, and in this case also a grid gap of 10 pixels, we'll automatically get a grid, which is pretty neat. This is what we call an implicit grid. We haven't defined any columns or rows yet, so the content defines them automatically for us. In this example, I have 5 grid items, so the grid is created and by default flows the content vertically down the page, creating 1 column and 5 rows. And this differs from Flexbox, where the default is to flow content horizontally across the screen. If we look at the grid tracks created, we can see the horizontal and vertical track lines that intersect to create the grid. And that's an implicit grid. Although pretty cool, they don't really give us that much control over the layout. In most scenarios, we're going to need to define a set number of columns and sometimes a number of rows as well. And this is what we call an explicit grid. So if we go back to our original container, but define a number of columns by adding grid template columns to the CSS, we get 2 columns that are 150 pixels wide each. Both grid template columns and grid template rows essentially tell the container what the grid should look like. Each column and row can be given an explicit value. In this example, we've given grid template columns 2 values of 150 pixels. We haven't defined grid template rows yet, so they are still auto-placed. But we can also set grid template rows like this. In this example, we've set the middle row to be 100 pixels tall. And this becomes really useful when using grid to control layouts of individual components. We can as well name the track lines. So track lines are the horizontal and vertical lines that intersect to create the grid. They're not the columns or rows themselves, something that tripped me up when I was first using grid. So here, for example, this 2-column grid actually has 3 vertical track lines. Track lines can be extremely useful when positioning content explicitly within the grid. For example, by using the track line names, we can easily set all odd columns to start at body start and end at column middle by using the shorthand of grid column start, grid column end, and set all even columns to start at grid column middle and end at body end. We can also use this to span multiple columns. Here we've set the 5th item to start at body start and end at body end, spanning both columns. And naming track lines can really help make your CSS much more readable. But you don't have to name them. We can place content by using the numbers as well. This is especially useful if you're working with large grids where it's just unnecessarily time-consuming to name all of your track lines. You can, of course, also apply the same positioning to rows using grid row, and you could even take this a whole step further and combine the two by using grid area, which is something I'll touch on later. Here, by using grid area, which is shorthand for grid template area, we combine grid template rows, grid template columns, and grid template area properties to tell the grid item to start on row 2, column 1, and then to span 2 rows and 1 column. The CSS Grid specification has also added some new units and CSS functions as well, which are pretty cool. The FR unit, which basically stands for fraction, allows you to size your grid, columns or rows according to a proportion of the available space in the grid container. And this is really super useful. So if we go back to our example earlier, where we set 2 columns at 150 pixels each, if we were expecting this grid to be a maximum of 300 pixels wide, this would actually be too wide and could cause nasty horizontal scroll bars on your page. And this is because of the grid gap. By adding that as well, the available space for the columns is actually only 145 pixels each, not 150. Changing the width of the columns to 50% each wouldn't help either. Again, the grid gap gets in the way. And we could get around this by doing some calculations to subtract the grid gap from the amount of each column. Or we could just use the new FR unit instead. Now, our grid columns take up an equal space, but there won't be any of those nasty horizontal scroll bars. And this is because the FR unit takes into account the grid gaps applied and subtracts the correct amount from the overall space available. This is another handy function, repeat. Going back to our example, we've used repeat here to repeat the value 2 times instead of writing 1fr twice. And just for kicks, I've also added in grid template rows as well, so you can see it applied there. Min-max is another one. This one allows us to create really dynamic, flexible layouts, but still has just the right amount of control over them. So in this example, we can see that there should be 4 columns in total. 3 are set to 1fr, so we'll use the available space equally. Column number 3 is set to have a minimum value of 150 pixels and a maximum value of 1fr. So here we can now see that while all the columns are wider than 150 pixels, they will fill the same amount of space equally. This column 3 has a minimum width set. When the browser window gets smaller and the columns reduce in width, column 3 stops reducing when it gets to 150 pixels wide, but the other 3 columns continue to get narrower until they collapse in on themselves. So that's some of the more common concepts. There is a load more I could show you, but there really isn't time to cover literally everything. So let's take a look at putting some of this into practice. So in this section of the talk, I'm going to show you 2 different ways you could use CSS Grid in your next project. This place and may not be perfect for every scenario, but also each shows the potential of what can be done and will hopefully inspire you to go off and create some layouts, amazing layouts of your own. So this first example is the no breakpoints approach. What I like about this is it gets us thinking more about the element on the page rather than the screen size, a lot like container queries do. So imagine you have like a recommended reading section or latest posts or products for you or something similar to that on your site. It would often look maybe something a bit similar to this. Before Grid, this is something I would have used Flexbox to create the layout for. Before that, I would have used display block and floats. Either way, I would have controlled the number per row by using a breakpoint, immediate query. But what if we don't need breakpoints and media queries to achieve this? What if we had a way to control the content so that it best fits the space it has available? Well, with Grid, we can do this, and it's actually really simple. And this is all you need. So here we've set display grid and then made it an explicit grid by defining grid template columns. And this is where the magic happens. We've combined the repeat and min-max CSS functions, but this time made use of the autofill value to repeat and autofill the columns instead, making it so that the row will display as many columns as it can. There are a minimum width of 200 pixels and a maximum width of whatever space is available. As the row expands, if there isn't enough room for it to add an additional column, the columns will fill the available space equally. And when enough room is created for another 200 pixel width column, it will add that column to the row. What's also nice about this example is when thinking about progressive enhancement, we can create a default approach to this with only a few extra lines of code. And then the cool fancy CSS Grid stuff will only apply in those browsers that support it. For this approach, I think a minimal viable experience would be to use Flexbox as the default layout because it is supported in IE 11, although there are some flex bugs. So I'll set that first and give all items within a margin of 10 pixels to create an equivalent of the grid gap, because sadly that's not fully supported in IE 11. Also, call me superstitious, but I believe that IE fallbacks only work when you include the sad face trash can and fire emojis in your code base as well. So I've now added my grid stuff, but I've wrapped it in @supports so that if a browser supports Grid, it will use this code again instead. @supports is a neat little feature that, although it's not part of the Grid specification, it allows us to call things based on whether the browser would support it or not. Here, Flexbox doesn't provide exactly the same experience. For example, the grid items wouldn't auto-flow to fit space available, but it's close enough to provide a nice enough experience in older browsers. And even with the defaults for Flexbox, you have far less code than if you had media queries and breakpoints to try and control how many items displayed on each row. So the next example is what I call the no wrapper approach, or flexible gutters. This is something I've been finding especially useful when dealing with full width content, especially in the WordPress space. Often when we want to control the width of a grid area, we will do something like this. This is great, does exactly what we need, and still a perfectly valid technique. And in fact, I will come back to using this later in another example. But let's have some fun and use Grid to control the entirety of the page's layout. So there looks like there's a lot going on in this example, but we haven't done anything here that we haven't already covered. What you can see is I've named specific grid tracks to define the start and end points of the 3 key template areas of my page, the main content area, and another column on each side to create the site gutters. And visually, that would look something like this. Here you can see how body start and container start define the left gutter, container start and container end define the content container itself, and then container end and body end define our right gutter area. Then, using the min-max function we also used earlier, as the browser window changes size, we have a content area that will never be narrower than 300 pixels and never wider than 1280. And the page gutter will fill the available space but never get narrower than 10 pixels. And that would look something like this. No, that's not going to play. Let's try that again. Nope, that's not going to play. So in this example, the blue areas show the gutters. As it draws in, the gutters collapse down to 10 pixels. Now this is a pretty simple example so far, and it gives us a content area and gutters without needing to use reactive. But why is this so useful? Well, there's lots of ways you could use this approach. One way is, as I've said before, with different width content options, especially within the WordPress space where you've got people creating that content in an editor, we can place full width content anywhere within the page. So we can create things a bit like this. I'm sure you'll agree this is a pretty common layout pattern now. There is a title, a general text area, and also a hero image or banner that fills the width of the screen. And in the not too distant past, to achieve this, we would have needed to use something like this, some clever trickery with negative margins and the VW unit to actually break out of the container or wrapper to create full width content. But by applying grid to the entire page, we can instead use grid placement to place the content using the first and last track lines that we named body start and body end. Using grid here gives us more than just flexible gutters though. It does allow us to place content anywhere on the page and at any width, which I think is pretty cool. And we could also create more editorial styles, maybe a bit like this. So this isn't a very complex example. I'd argue it's probably not even a good example, certainly of my design skills. But I hope it gives you an idea of what can be done. If we revisit the grid layout we originally created, you should be able to see how this content was placed into such a simple column grid to create something visually appealing. There are a couple of small things I've changed, but the only real difference between this and the original grid is that I've now also defined template rows as well. So the code for the grid template started as this, but now also has this added to define the rows as well. And hopefully by now you're starting to recognize this. Again, here we've defined 3 main content areas, but this time they consist of a total of 5 rows and all have a different FR value. What's happening here is, if you remember, an FR unit is a fraction. So if you think of the page being divided into the total number of FR units used, this page would then have a total of 15 equal parts. The first content area would take 1 part, the 3 rows of 3 FR would take up 9 parts of the page, and the last content area would take up 5 equal parts. Which, if we view the layout again using Firefox's Grid Inspector, we can see how the content's been distributed across the rows and the columns. Hopefully that gives you some idea of what you can do with even the simplest of grids. The idea here is not to advocate for the wrapper divs or breakpoints are bad, only that Grid gives us ways to control our content across devices and browsers without us always having to rely on those breakpoints or extra markup. This can make our code more lightweight and much easier to maintain as well. Now, I said earlier, I was going to show you 2 examples of techniques you can use in production now. This last example I want to show you can't be used yet. It does combine both of the previous examples, and it also uses both breakpoints and a container div. And hopefully you will agree that this is pretty excellent as well. And this is using subgrid. So as I said, this isn't available in production yet. I was looking again today and I still can't find a date of when this will actually drop and will be available for us to use in any way other than behind flags. But when it does, it's going to change all the rules all over again. So going back to our original no wrapper approach, but this time, instead of only having 1 column in the main container area, we'll combine the repeat function with the min-max function to give us 3 columns that each have no minimum width, but a maximum width of 400 pixels each. Combined with the grid gap value, it gives us a container area that is 1220 pixels wide on desktop. So our grid would now look something like this instead. We still have our outer columns that create our gutter and collapse down to minimum size of 10 pixels. But we now also have 3 columns within our container area that you can place content into as well. At the moment though, in order to place content items only in the 3 columns within our container area, we would have to do something a bit like this. We're using the track line numbers rather than the track names to target the track lines within the container area only, and then media queries to explicitly place the content in different positions at different breakpoints. On mobile, we're setting all grid items span all 3 of the central columns, so there's 1 per row. And then on desktop, they span 1 each column to display 3 items per row. And this is fine, it works well, but if we think back to the first example I showed, we don't want to select all of the grid items and explicitly place them and then change that placing at different breakpoints. We want the content to flow and fit the space available. The subgrid can solve this for us. Firstly, we need to change our grid so that the columns in the container area are now repeated with using an autofill value and combine that with our min-max function. This will mean that our 3-column content area will now instead fill the available space equally, and when enough room is created for another 400 pixel wide column, it will add that column to the row. Now we can add a new container to the page for our grid items. Using our named track lines, we can place it to span our content grid. Then we need to start placing our content using the grid we've created, but inside of the new container. Normally with grid, to achieve this, we would have to define a separate new grid and apply it to that container, essentially duplicating the original content area defined in our first grid. But with subgrid, we don't need to do this. First, we apply display grid to the container. Then for the grid template columns property, we apply a value of subgrid. This will then take the column settings we had already set up from the parent grid, instead of having to define our parent grid and then define a separate child grid as well, which is pretty cool. Now, so we've added the subgrid stuff. We can create layouts that look like this by defining the entire layout in 1 grid. As we scroll down the page, we can see we have content that is full width and also standard content that fits within the container area, and a list of posts that will autoflow based on the size of the screen. And this specific example is in my code pen if you want to have a look afterwards. So I didn't show you all of the code for this page, and I'm sure you can all agree that using subgrid here is way cleaner than having multiple container divs for sections and breakpoints to control everything. And this is only one example of using subgrid. Another example would be for hero areas where you've got content inside that maybe has to line up with the content on the rest of your page, or a whole number of different ways. As of right now, you can only experiment with subgrid by using Firefox nightly, but I highly recommend you do have a play around with it, as it really is powerful, and hopefully it will ship soon. So hopefully this has been a pretty exciting adventure so far, but Grid isn't perfect and there are a few gotchas that you need to be aware of. Content ordering isn't a new concept. It was introduced with Flexbox, and it can be super handy, but it should be used with extreme caution. So if we go back to our earliest example of a grid, which looked like this, what we could do here is rearrange the visual order of the grid items. We would do that by targeting them. So here I've used nth child to select the third grid item, and by applying an order, we can move it so that it displays as the fifth item instead. We can also achieve this by using placement. Again, going back to one of the earlier examples. Here we use placement to set the fifth item to start at body start and end at body end and span both columns. But if we actually wanted that fifth item to display as the first item, we would make use of both grid column and grid row and explicitly place the item in the grid like this. So here you can see I've used the track names to place the content in the first column, and then use the track numbers to also make sure the fifth item actually displays in the first row. This then forces all of the other grid items to autoflow from the second position onwards. So what's bad about these examples? Well, although visually the order has changed, the source order has not. This can be very bad for your website's accessibility and will affect those people navigating using keyboard or screen readers. In this example, people using keyboard tabbing to navigate the grid items would start at the second item, tab down to the fourth, and then jump back to the beginning for the fifth item. This isn't what they would be expecting and would create a jarring experience for them. So the next gotcha is always the elephant in the room when talking about CSS Grid, and that is its Explorer. And this seems to be the one thing that puts most people off of experimenting with CSS Grid, but there is some support for it. And for the part of the spec that it's not supported at all, there are other ways to create a minimum viable experience for older browsers. So Rachel Andrew gave us a great article back in 2016 that looked at the spec between the new and the old to see which bits were supported or not. And then also she did a follow-up article in 2018 about whether you should even try to support IE anymore. And the short answer to that is, in her article, is no. It's probably not worth the effort now, unless you need to do something specific that only Grid can achieve. And I mostly agree with that. However, that doesn't mean that you won't ever find yourself in a situation where you have to provide support. So it's still worth taking the time to understand the differences between the modern specification and the IE 10 and 11 spec. Probably the most common issues are around prefixing. It is very tempting to rely on auto-prefixer for all the things, but it can't automatically prefix everything for CSS Grid. Therefore, you still have to know where it can and can't help. For example, here we've created a simple grid containing 2 columns and 3 rows. In order for this to work in IE as well, we would need to add 3 new lines, and these are an additional display property with MS Grid, and then grid template columns and grid template rows now have a prefixed MX version as well, MS. Also note how we've not used the repeat function on the grid rows and grid columns either. And that's because although repeat is super useful, it's sadly not supported at all. Instead, this would need to be written manually. And this is an area where using auto prefixer would catch us out. While it can automatically replace grid template columns with MS grid columns, it can't update the usage of the repeat function as well. Therefore, if there were 16 grid columns, we'd still have to write out one FR 16 times. With these MS-specific additions, we are part of the way towards getting our grid working in IE already. However, up until auto prefixer version 9.4.0, which I think came out about 18 months ago now, there was another key feature that was not supported at all, and that is auto placement. Now, although there is limited support for this now, you will often find a project that has had to find creative ways to get around this, or at least I seem to always find projects that have had to do this. So I'm still going to cover this briefly. Without support for auto placement, we still have to manually place all the grid items. If we don't, then every grid item will display in column 1 and row 1 in IE 11. I will admit this does look hideous, but it shouldn't seem too unfamiliar now though, because we've already covered placing content in some detail. The difference here is that there is no shortcut to specify both the start and end. Instead, MS grid column replaces grid column start, MS grid column span replaces grid column end. And that is a lot of code. But if you use Sass or Less or another preprocessor, I'm pretty sure Post CSS has got some functions for this sort of thing. It can be tidied up with a repeatable bit of code, in this example, a mixin. And all this is doing is asking for the values for where the column starts, ends, where the row starts and the row ends, and then applying them to both the standard grid properties and also the IE fallbacks, which when applied would look like this. I'm sure you agree, it's much nicer when you see it like this. And this is just one mixing example to beat the volume of code needed to support IE and speed up development time. There are loads of ways you could do this. It just entirely depends on your layout and what you need it to do. But I did just say there was a newer version of auto prefixer, and it does come with some partial support. So auto prefixer 9.7.0 can now provide some auto placement support if we use grid template areas instead. So in our previous example, we would set up our grid template columns and rows, and then maybe use a mixin to set the column and row placement, including the MS prefixed fallbacks. With the new auto prefixer, we can make use of grid template areas, and by extension, the grid template shorthand instead. So here, we're using grid template to define the rows, columns, and the sizes of each row, So in this example, we've created a 3-row and 3-column grid where all rows are set to 40 pixels high and all columns are 1 FR wide. So A spans 3 columns, B spans 1 column and 2 rows, and C spans 2 columns and 2 rows. What I like about grid template is it does give you a nice way to visualize your grid if you lay it out like that. However, it can get really super complicated if you're creating complex layouts. And I will admit I've used this only very sparingly. But auto prefixer would give us something like this. So now we can see that the columns and rows have been specified with the MS prefix, and our grid item also has the MS prefixes added. However, the new auto prefixer still doesn't solve all of our problems though. It still doesn't support row and column span, so we would still have to add the MS grid column span manually for our first grid item to span all 3 columns. We also still have no support for repeat or min-max, and grid gap is only partially supported. And that's only if you remember to specify the gap for both template columns and template rows. And of course, if none of this is working for you, it's still perfectly okay to use @supports instead, as I showed earlier, and just use a different layout method as your default. and only use Grid where it has the proper support. It's important to remember when supporting older browsers, the aim is not to provide exactly the same experience across all, but instead to allow the layouts to degrade nicely and ensure you provide a minimum viable experience. If you are interested in more detail on how to support IE, I did write a series of posts last year after I had to retrofit a project with IE, and I've included the link here. I don't actually blog very often at all, so you'll be able to find it easily. So to wrap up, Grid is awesome, I think. Hopefully you all agree. It is the first two-dimensional layout system introduced to CSS. You can control both the column and row layout at the same time, which differs from the likes of Flexbox and Display Block. We can control entire page layouts with far less CSS and HTML markup, giving us flexible gutters and the ability to build much more complex layouts. Grid can allow content to flow within the space it has available without us having to add a lot of extra code to control that. It's supported by 94.47% of all browsers now. Internet Explorer is not the elephant in the room and should not be a reason to not use CSS Grid in your next project. There are plenty of ways to work around the differing specifications now. Subgrid, when it finally arrives, will be even more awesome. So hopefully I've inspired you to go off and create some amazing layouts of your own. The CSS Grid specification really does make it easier to change the way we think about flexible design and layouts. We're no longer constrained to specific pixel perfect requirements. Our content can flow based on the amount of space available. And really, for me, this type of flexibility is what makes responsive layouts so very exciting. Thank you very much for listening.
Okay, thank you so much for the talk. So let's see if we have some questions. Yes, we have a lot of questions actually.
Oh,
let's see if we have time until midnight. So let's start with the first one. Is it advisable to mix Bootstrap and CSS grids? Can you imagine any examples so it would make sense?
I don't see any reason why you can't. I mean, it's been a long time since I've used Bootstrap, so their grid system is slightly different. But I would imagine that they're moving that to use CSS Grid anyway, because this is becoming the standard. I think if you're using a grid system in Bootstrap for the layout already, maybe explore using CSS Grid for smaller component layouts. So if you've got a specific card layout that you've got an image at the top and 2 columns and a heading, perhaps experiment using Grid there rather than trying to get that to work with an already existing grid system.
Mm-hmm. Okay, then another question, when to use Flexbox and when to use Grid?
Both have their uses. What I tend to do is I tend to use Grid for larger layouts and Flexbox for anything that needs to be a little bit more flexible. So, for example, if I am building an entire page, I'll quite often use Flexbox to control different elements in a header area, like the logo and the navigation, and if there's like language menus and things, because that needs to be more flexible across different screen sizes. Whereas with Grid, I'd use it for the entirety of the page. It really depends on your use case.
Mm-hmm.
Don't know if that really answers it.
There's a related question. So is it true that it's better to use Flexbox for smaller projects or let's say smaller layouts? Depends, right?
Yeah, it very much depends. It really depends on what you're trying to achieve. If you don't need 3 explicit columns in your layout, you maybe just need 2 to expand more, or you need to change the direction, then Flexbox, I mean, it's just at the risk of sounding like I'm putting a pun across, it's just more flexible with smaller things. So it's where I tend to use it more.
Mm-hmm. Another Flexbox question. Can you use CSS free grids with inside a Flexbox container?
You can't apply the display property of Flex and the display property of Grid to the same container. If you have a container that has display Flex and then inside that is another container that has display Grid, yes. Yes, you can. I don't.
Okay.
Yeah.
Then let's move through the questions. What if a hidden item element is in a grid column? Does the rule still work on it?
Sorry, if an item is hidden.
Yeah, I'm also not if an item is hidden. So I would say like maybe if an element is set to display none or something, is in the grid column the rule works on it? Question mark.
Yes, so if you've applied the grid to your container, then that's a grid on your container that will affect all of the content. So if you've got items in there that are set to display none, they'll still be positioned where you've positioned them. I think if the question's more about if you set the grid container to display none, I actually don't. No, it won't, because it's a display property. So the display none will replace the display grid.
Mm-hmm. Okay, then what is the difference between autofill and autofit, and what about browser support?
So browser support for autofit and autofill is very similar. It's the same, because these are parts of the CSS Grid specification. So anywhere CSS Grid is supported, they will be as well. I'm going to put my hands up and say I can't describe the difference between autofit and autofill. They are very, very similar. I have used both, but I tend to stick with autofill because it does what I'm expecting it to do. Okay. So it tends to be what I use.
That's fair enough. If it works, then it works, right? So is subgrid supported in every browser? Is the next question.
No, it's not yet. It's at the moment. It's only supported in Firefox in their developer edition. So eventually, it will get released to all, but we're still waiting for when that will actually happen.
Yeah, let's hope. And why do you like shorthand CSS rules?
Usually just so there's like less lines to actually manually write out. I just find them tidier, I think, is the thing. I like my style sheets to look tidy.
Okay, and then there is one question, but it's a bit unrelated, and it was posted 40 minutes ago. It's just basically says display inline block is an option, question mark. So I'm not sure to what slide it was related.
Possibly the beginning. Yes, display inline block is also, I mean, it's another option as well. It was used quite often definitely for like horizontal navigation things. And it definitely still has its place. Grid doesn't replace that.
Okay, so this was already the last question. And with that said, I just want to say thank you very much, Kirsty. It was a very nice last session of the day. And I hope that we can see you soon also at other events, also physical events. Let's hope.
Yes, one day.
And yeah, greetings from Vienna to the Midlands.
Greetings. Thank you very much for having me.
Bye-bye. Okay, folks, so that's it for today. We have finished the WeAreDevelopers live day, the second day of the event. Tomorrow we are having our third and last day. We will talk about micro frontends, we will talk about Angular, Webpack, and we will talk about Svelte. So tune in to learn something about these topics. I want also to say a big thank you to JetBrains, who have been the partner of the day and make this event possible. So thank you, JetBrains, again. And with that said, Last but not least, if you are looking for a job or if you want to scan the market, then please visit WeAreDevelopers.com. You can find there a lot of jobs in Europe, and you can check the salary information on many jobs up front already. You can check your match with these jobs and directly apply. So if you're interested or if you want to scan the market, then just go forward and check it out. With that said, I say bye-bye from Vienna and see you tomorrow again.
Business go hybrid. When you're a chef running a kitchen,
artichokes, please.
Things can change quickly. The branzino isn't selling, the ribeye selling out. My floor manager's wife just went into labor. Getting things prepped beforehand can help you put out fires. Literally. That's what a hybrid cloud approach with IBM can do for your business. It lets you automate processes across all of your clouds to get ahead of problems and earn rave reviews.
Dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.